Welcome to the new course, where we will talk and get to know Bicep. In the initial part of the course, we will learn the basic concept of Bicep, get acquainted with the Azure portal, and how to create resources in this cloud provider. Also, during the course itself, I will try to present all the resources and services that we will create and with a detailed explanation. We will spend a good part of the course in Visual Studio Code, where we will write our scripts or files, and one part of this course is dedicated to real-life projects. At the end of this course, you will have a good knowledge of Bicep, enough to be able to continue learning, but also to add a new item to your CV and resume. Welcome once again to the Bicep course. It's time to start this course. Before we start learning, allow me to introduce myself. My name is Vladimir Živković, and I'm a certified Microsoft trainer, or MCT, and Azure Cloud Solution Architect. In addition to these certificates, I have several Azure and AWS certificates. As you can see, I have AZ-104, I have Azure Solution Architect, also I'm an MCT, as I already told you. Then also I have some AWS certificates, and I was Udemy instructor, almost 5 years. Also, I have spent a good part of my career working in the cloud, with considerable experience in the concept of the Azure cloud itself. I spent 5 years as a Udemy instructor, and most of my courses were part of the premium offer, like AZ-900, AZ-104, AZ-500, AZ-700, AZ-305, SQL Database, Cosmos DB service, Entra ID service, Ubuntu Linux, Docker, Kubernetes, and container services Azure. Also, there was AWS course over 100 hours of material. Unfortunately, many of you have witnessed that Udemy is not what it used to be. So, like many other instructors, I have decided to leave them and withdraw all my courses, mainly due to disagreements with their policy toward users. But all this will not prevent me from delivering the best possible course on Bicep, on YouTube, of course. After all, as you are used to, all my courses are extremely detailed and full of labs. Also, if you want to hear from me or have a comment, or if you want to get a touch or contact with me, you can find me on LinkedIn with my full first and last name. Of course, all these certifications and titles are enough to consider myself that I am capable to present you this course. So, let's continue to the next chapter of this course. For those students who are not familiar with automation and Azure itself, before we move on, let's get to know what is automation and what is Azure. In the Azure context, automation refers to a service that enables routine tasks and processes in the cloud to be performed automatically without the need for constant human intervention. It is part of the broader concept of cloud automation and is used to save time, reduce errors, and increase efficiency. So, when we talk about automation, let's see what are the key features of Azure automation. So, first is Runbox. You can use scripts, most often written in PowerShell or Python, that define the steps to execute a specific process, like automatic start or stop, VMs, patch management, or some backup. We have update management. Then we can use automated installation, for example, for security patches, or updates on any Windows and Linux machine in our environment. The third key feature is configuration management. You can use something called desired state configuration or DSC to maintain a consistent state of resources. Also, you can process your automation, like doing a management of complex businesses and IT processes through orchestration and automation. And the fifth key feature is hybrid worker. Allows automation to run not only in our Azure environment, but also on local servers or other cloud environments. Some key examples of use of Azure automation, I already told you about some automatic start or stop VMs. So you can automatically shut down VMs during off hours to save cost. So if you're working on Azure and you have some VM that hosts your application, you can automatically write a script that will execute your command during night, for example. And your business runs from 9 to 5, for example. And in that script, you will have to write or define the steps that execute that specific process, that your VM will be off or deallocated during that time. So it will save your cost. Also, you can use some regular service patching without manual intervention. You can do orchestration of complex deployment processes, manage the configuration of application and services to remain in your desired state. In simple words, Azure Automation is a tool for orchestration or orchestrating and automating IT operations for simple tasks to complex processes. On the other hand, when we talk about Azure is Microsoft public cloud service. This is a global platform that enables organizations and individuals to use infrastructure, applications, and services over the internet without having to maintain physical servers or complex IT systems themselves. Some core components of Azure is, as you can see on our picture, cloud models. So the first, as you can see, is we have our premises. Just let me use my pen. The first cloud model is on-premise. What does it mean? If you work in Azure and if you use cloud services, before cloud there was a hybrid. There was on-premise. In the on-premise environment, the company itself was forced to buy equipment and spend a decent amount of their budget to servers, for example, virtual machines, networks, data storage, and so on and so forth. So you as a person as a company was responsible to manage networking, storage, servers, virtualizations, OSs, middleware, runtime, data, and applications. After years of working, Microsoft introduced Azure and its cloud services, platforms, and now we have more options. For example, the first option is Infrastructure as a Service or AIS. Here we can find, as I already told you, virtual machines, networks, data storage, and we, as a user, as a company, we get the basic infrastructure and manages the application ourselves. So, as you can see here, we, as a company or as a user, we are responsible for applications, data, runtimes, middleware, and operating system. But Microsoft, as as a provider, is responsible for networking, storage, servers, and virtualizations. Then there is Platform as a Service, or PaaS. This is a ready-made platforms for developing and hosting applications. So we, as a customer, we are responsible for applications and data. But Microsoft take care of the rest, like runtime, middleware, OSs or operating systems, virtualizations, servers, storage, and networking. So you, as a user, you just focus yourself on the code, and Azure take care of whole infrastructure. And the final one is software as a service. Here Microsoft is responsible for everything. As you can see, this is just a ready-made applications available over the internet, like Microsoft 365, which is integrated with Azure services. This is just the basic core components of Azure services. Also, we have key areas of applications. We have, for example, compute. In the compute, we have virtual machines, containers, some serverless functions. Then we have storages. We can find blob storage, disk storage, file shares. Then, just like in our on-premise environment, we have networking, virtual networks, load balancers, VPN gateways. Then, for the security and identity, we have Azure Active Directory or Microsoft Entra ID. We have Key Vaults, for example, which is a service that stores all your secrets, keys, or passwords, for example. Then we have data and AI services. They belong to Azure Machine Learning, Synapse Analytics, cognitive services. And finally, we have DevOps and automation. We have Azure Automation, Logic Apps, GitHub Actions, integrations. Also, when you heard, for example, cloud, you can imagine where it is used. For example, for Azure itself, we can have some more terms like scalability. Here, capacity is easily increased or decreased. For example, if you have some virtual machine, your virtual machine can be size of your virtual machine, for example, can increase or decrease vertically or horizontally. Azure is global available. We have a lot of data centers around the world, as you can see. So, for example, you can choose whatever region is closest to you, and then you can save money or reduce latency and so on. Then, for the security point of view, they have advanced controls and compliance certificates, integration with other third-party tools or Microsoft ecosystem is very easy. So Azure Cloud is the foundation for the modern IT ecosystem, from web application hosting to complex analytics and artificial intelligence. This is just a simple presentation of automation and Azure. For those students who are not familiar with what is automation and Azure, I hope that now is more clearer. If you are already familiar with these terms like automation and what is Azure, you can simply skip this lesson, but my intention as a trainer or as an instructor is to present these terms. Let's go to another lecture. When I decided to record the Bicep course, I thought about how to structure this course itself. Since the structure is one of the most important aspects when you start planning to record a course on a certain topic, and it is not related to the official MS Path or Microsoft Path, I decided to start from the basic, so that as many people as possible could understand what we can do. The beginning of this course is dedicated to the people, to the basics and after we create our workspace or environment, I will try to present the services to you through individual examples, first in the portal and then by writing a bicep file in Visual Studio Code. Of course, when we get to certain parts, I will additionally explain the concepts themselves, and especially we will have additional explanations when we do a real-life project as well. This approach will provide everyone with enough visual and theoretical material to get to the heart of biceps and get the maximum value out of this course. Since many of you know me as an instructor from Udemy platform, most of these comments that are coming below my AZ900 course, which is also available for free on my channel. So I advise you to go and check that course. It is a real 20 hours of pure theoretical and practice. You can ask yourself, why is this course free? So, as I already told you, one of the frequent questions that instructors get, no matter where they're teaching, is when they decide to share for free. How it is possible that this kind of course is free, which of course you have to pay on your Udemy platform, of course, from different instructors. What do you get out of it? What I get out of it? Will you have any benefit from YouTube and similar questions? Well, the answer to all of these questions is mostly no. When it comes to some material gain, and one, yes, it is possible that this course is free. The second thing is that during the years of working on various projects as an advisor, consultant, or part of a team, and lately also reading various comments on forums, is that people, apart from the certificates they acquire by passing, do not give enough time to automation, which is required by a good part of employers. Of course, in the academy where I teach cloud, a good part of this official Microsoft learning path contains a lot of PowerShell information, a lot of CLI information, bicep information. So it is a good practice to know all these languages, or simple to know JSONs, JavaScript object notations, or ARM. Well, your employers required a good part of this, so automation is now must-have. In today's time or world, it is not possible to have only theoretical and manual knowledge that you can implement in or from your browser. As I said before, I noticed that a good number of people do not understand ARM, Bicep, Terraform, PowerShell, or any other language that you can use to build resources in Azure Cloud. If you're planning to go down this path and you don't have enough experience with automation and Bicep, then this course is for you, of course. It doesn't matter if you're a developer, administrator, etc. Once again, this course is free because this is my desire to help people learn Bicep and understand the importance of automation. Now, let's get to know what is IAC. Infrastructure as a code, or AIC, or something called AIIC, is a modern approach to managing and provisioning IT infrastructure through code, rather than manual processes. There are some key points when we talk about infrastructure as a code. The first one is definition. Infrastructure as a code means writing scripts or configuration files using languages like JSON, YAML, or domain-specific tools such as Terraform, Bicep, or ARM templates to define and deploy infrastructure resources. Also, the term automation, instead of manually setting up servers, networks, and storages, infrastructure as a code automates the process, ensuring consistency and repeatability. Also, you can use different version control because infrastructure is defined in a code. It can be stored in repositories like GitHub, versioned, reviewed, and rolled back just like application code. Also, consistency is one of the benefits using infrastructure as a code. It eliminates human errors by applying the same configurations across environments like development, testing, production, or UAT, for example. Scalability allows teams to quickly replicate environments or scale resources up and down as needed. With infrastructure as a code, you are write a template that specifies a virtual machine, for example, with certain CPU and memory. So using this code, you can define what the number of CPUs and how much memory your virtual machine will have in, for example, Azure cloud or in AWS cloud or in GCP. Then a network will have defined security rules if you choose to do so. So you can do also with the help of infrastructure as a code. You can, for example, use a database with backup policies. So with working with infrastructure as a code, the possibilities are endless. Running that code will automatically create the infrastructure exactly as described, and it will do every time. So now that we know what is infrastructure as a code, let's learn what is a bicep. Once again, if you're familiar with all of these terms, you can simply skip this part because we are learning just the basics, and now it's time to learn what is a bicep. Well, bicep is a domain-specific language, or DSL, created by Microsoft for deploying Azure resources declaratively. It's designed to simplify the authoring of Azure Resource Manager, or ARM, or ARM templates, which are traditionally written in JSON or JavaScript object notation and can be verbose and complex. So when we talk about biceps, let's learn some key points about this language. The first one is simplified syntax. Bicep use a clean, concise syntax that is easier to read and write compared to a raw ARM JSON templates. So if you already work in Azure, when you try to create some resource with the help of ARM, there is hundreds and hundreds of lines of written material. Well, Bicep use this simplified syntax, and all these ARM templates you can translate to Bicep. Also, it's Azure native. It's tightly integrated with Azure Resource Manager, meaning anything you can deploy with ARM, you can deploy it with Bicep. It is also declarative, so you can describe what resources you want: VMs, storage accounts, networks, and Azure takes care of how to provision them. It's idempotent, that means running the same file, Bicep file, multiple times won't create duplicates. It ensures that desired state is maintained, and this is why I love to work with Bicep. Also, it works seamlessly with Azure CLI and Visual Studio Code, offering validation, IntelliSense, and resource discovery. Also, Bicep file compiled down to standard ARM templates, so you can always see the underlying JSON if needed. So transparency is very, very good. Biceps is the next generation language for Azure infrastructure as a code, making deployment faster, cleaner, and easier to maintain. So, if you are administrator, my advice is to go and learn Bicep. Let's see how can we create a free Azure account. But before that, let's see our table. What is the difference between Bicep and Terraform? As you already know, Terraform is multi-cloud language. Azure is only for Azure. Of course, you can use Bicep for AWS, but I will advise you to use Bicep only if you're coming from Azure environment. Let me just grab my pen and I will help you to understand what is the difference between Bicep and Terraform. So both are specific languages. We have Bicep, which is only for Azure native, and multi-cloud, which is Terraform, of course. You can use Azure, AWS, GCP, etc. When you talk about syntax, Bicep is declarative, concise, designed to simplify ARM templates. Well, when you talk about Terraform, each HCL or HashiCorp configuration language, flexible but more verbose. Integration, it is deeply integrated with Azure Resource Manager or ARM. On the other hand, Terraform works through Azure RM provider, and it also supports many different providers. A learning curve is easier for Azure users, especially if you're familiar with ARM. When we talk about Terraform, it has a broader learning curve, but transferable across different clouds. Tooling built into Azure CLI and VS Code extensions. Terraform is independent tool, strong ecosystem with different plugins. Of course, when you talk about state management, there is no external state file. It relies on ARM. When we talk about Terraform, it uses a state file to track resources, enabling drift detection. Best use case for Bicep, you can only use to pure Azure projects for quick deployments and tight integrations, because this is only Azure native language, domain-specific language, as you already mentioned. And then we have Terraform, which is a multi-cloud environment, complex orchestration, and you can run hybrid setups. When we talk about community and ecosystem, Bicep is backed by Microsoft, and it has a really growing community. When we talk about Terraform, it has a large mature community, extensive module registry. So the difference, once again, between these two languages, it really doesn't matter if you're learning Bicep or Terraform. If you have some experience from the companies where I work in different companies, of course. When people using Terraform, they are more convenient to use when they want to work with, for example, AWS or GCP. They use for Azure, but not so much. So I will recommend Bicep because this course is for Bicep. If you're coming from, once again, Azure environment, Azure world, then Bicep is the real thing for you. Let's create that free Azure account. Now that we have familiarized ourselves with the basic definitions, it is time to familiarize ourselves with the Azure portal. But before that, we need to create an Azure free account. In the next few minutes, I will show you how can you open a free account and what are the benefits that you get from Microsoft. After that, we will immediately go to our portal and do a short tour so that you can get to know our environment even better. So as you can see, we are in azure.microsoft.com, and here simply go to your browser and type Azure free account, and you will get to this address. So when you start working with Azure, the best thing that you can do is to open a free account. Just like any other service cloud provider, Microsoft or Azure are offering 30 days of free use, or simply you can try Azure for free. But first you must open this account. As you can see, if I scroll down, you can choose what type of account can you open on, or what you get with these offers. We have two offers. First is Azure free account. This is best for new users, and we have pay as you go. This is the best for customers or for users that have already tried this free account. For users that will try or want to try this free account, you can check all these offers here. It is available only to new customers. This is, you will get free monthly amounts of 20 plus popular services for 12 months. So after these 30 days, after your free account expire, you will get free 20 or plus free popular services for 12 months. This is good to know. And only for new Azure customers. Free monthly amounts of 65, always free services. You have access to full catalog of services up to free amounts, and the best thing is that you have $200 of credit that can use on different Azure services within 30 days. So within these 30 days, you can try different services and it will just deduct from this amount. Also, you have spending protection. Your credit card won't be charged if you go beyond that 200, and there is no upfront commitment. You can cancel anytime. You can move to pay-as-you-go offer pricing and continue this period beyond 30 days or after your credit is used. Also, if you already have your account, you can use pay-as-you-go. There are some different things that you must know. When you compare these services with pay-as-you-go, you have free access to full catalog or services with no cap or service usage, because you're paying only what you use. That's it. You have technical support option that is available. Also, there is no upfront commitment. You can cancel anytime, and no action required to continue beyond 30 days. So it's up to you. What do you want to use? Also, if I scroll down, you can check all these services. These services, as you can see, or products are free and specified to monthly amount. Some are always free to Azure customers, and some are free for 12 months, as I already said, but for new customers only. As you can see, for example, Azure Virtual Machine for Linux or Windows, you get 750 hours for each, for different series. For B series, for example, ARM-based or AMD-based burstable VMs. So this is a good to know, of course. You have, for example, a good amount of vCore seconds for SQL database, for Azure Data Factory, Azure Data Catalog, Azure DevOps, Azure Speech in Foundry tools, Azure Container Registry, and so on and so forth. You can explore all these free services by clicking See All Free Services. You can also learn more about Azure from these links, and it already, as a good practice, is to see FAQ or frequently asked questions, so you can check all these questions and get to know more in depth what are Microsoft offer us. And also you can check, is your Azure available in your location, and there is also more than 100 countries and regions that are available to users across the globe. Also, you can check that already mentioned that with Azure free account, free services, and 200 credits do not include sovereign cloud products in US government, Azure China, and Azure German region. Of course, you can find your location here and check everything. But let me show you how can you open a free account. But this is available only if you don't have one. Let me click, and I will click on create a new account. In the new bar, I will add or create a new account. Let me add my email address. Let me just find the appropriate one, and we can continue with creation of this account. And I will use my outlook.com. Let me click on next. Here I must create a password. This is a password for our account, and you can check or uncheck this if you want to receive some information, tips, and offers from Microsoft products and services. Let's click on next. Here I need to choose my region. I will choose my region, my country, my birthday date. I must enter my birthday. Let's click on next. Here we need to solve this puzzle so that we are proving that we are not a robot. Let me beat the robots by using this. Click on submit. Our verification is complete. And finally, we need to add our first name, middle name, last name, email address, phone, and then we will add our as you can see. Let's click on next, and then we need to add our bank account information, and after that the Azure will take $1 from your account just to confirm your identity. And after that, as soon as your identity is confirmed, then it will revert that $1 back to your account. So this is some kind of protection, and it is good to know that protection of your identity, of course, and then you can start using your Azure free account. Of course, I cannot open a new free account because I already have my account, and in the next chapter we will see what our Azure portal looks like. So this was a free option to see how can we create our free Azure account. And finally, we are in our Azure portal, as you can see, and this is how Azure portal looks like. For those who don't know how to work from Azure portal, I will take a free, as I like to call, tour to Azure, and I will explain the main options that are offered to us so we can start creating different resources. As you can see, this is my email address that I use when I create this account, and here you can see you can switch directory or simply sign out and so on. Also, when you look at this portal, the most used Azure resources will be shown here. As you can see, in the resources, as you start building your resources, the list of your resources of most of recent used will be shown here. Of course, you can always add your favorite resources and simply click on select resources to favorites, so there is a kind of shortcut here. You can navigate here to your subscriptions, resource groups, all resources, or simply use dashboards, or you can use these links to know more about what is Microsoft Learn, what is Azure Monitor, Microsoft Defender for Cloud, or simply use cost management. Also, in the bottom of this page is where are these useful links. And of course, you can download your Azure mobile app for Google Play, from Google Play or App Store. Here in the right side, we can use these 5 icons to give a feedback to Microsoft, check some knowledge, or if you want to contact support, you can write ticket from here. If I click on this little cog here, you will get some portal settings, directories plus subscriptions. Here in directories plus subscriptions, you can choose your default subscription. If I click on appearance, you can choose what your desired menu behavior and damming option. You can check some flyout, docked menu behavior, service menu bar collapsed or expanded, as you can see. Then you can choose the color of your background. You can choose between light and dark or auto. I'm using this default option, and you can use this startup view. Your startup page can be home, just like mine, or you can simply create your own dashboard and create your dashboard that will be your startup page. And startup directory, you can choose from last visited or select your new directory. I will discard these changes because this is my default options. If you click on language and region, you can choose your language and regional format. You can add your information here, and signing out a notification, you can enable directory level idle timeout, for example, for 4 hours or minutes. You can override that option. You can sign out when this, for example, if you are inactive for 15 minutes, then you will be signed out from Azure portal. Of course, you can check all of this box for notifications to show pop-up notifications, show a pop-up service, show teaching bubbles. And that's it. Of course, there is a lot of useful links here. If I click on Microsoft Azure, we will go to our front page. Here, the next option is, as you can see, notifications. Every time that when you create a new resource, then your notifications will pop up here. And there is something called Cloud Shell. Right from here, you can run your commands in PowerShell or Azure CLI. Of course, when you try to reach to some resources, you can use this search option. Here you can search for resources, different services, and documentations. For example, if I type SQL, for example, you can see that I get these services. This is SQL Server, SQL Elastic Pool, SQL Server databases, SQL Server instances. Of course, this is Microsoft Entra ID. Microsoft Entra ID, if you don't know, is identity provider and access management service in Azure. And there is also marketplace and different documentation. So this is search option. Of course, we have a copilot, your AI helper, that you can help to maintain and build your application, or simply you can ask copilot whatever questions you want. You can complete task, discover, and utilize different Azure services. You can use these predefined bubbles. For example, what are frequently used shortcuts for Azure Portal, and Copilot will give you AI generated content. And of course there is a warning that this content may be incorrect. And here it is. You can check all these actions. Here are some frequently used keyboard shortcuts for the Azure Portal, for example, actions. Then you can use this from your keyboard, or navigation, go to specific location, and so on. And you can continue and prompt more from here. Let me just collapse this. And finally, if I click on this portal, we have this favorite option with your favorites, different services. Of course, you can add your own favorites here, or simply click on, if you hover your mouse, you can click on this star and bookmark your favorites here. If I click on all resources, you can check all your resources right from here. Of course, there is an option to quickly create your dashboard to see all services, or go to home. If I click on create resource, we are automatically go to some place that is called marketplace, and you can search your services for marketplace. You can of course choose recently created, how to start. This is a popular services, as you can see, and popular marketplace products. And also all these products are listed here by categories. For example, if I choose databases, you will get all databases that you can find here. And finally, if I click on this some kind of hamburger menu or dot menu, you can find all Microsoft Cloud portals here. So for example, if I want to go to, let me see, Entra portal, I will open this a new link and I will go to Microsoft Entra Admin Center. Of course, this is center where I can work with my users, applications, and devices in, or groups, of course, in my environment. So you can go to GitHub, Fabric, Power Platform, Purview, Visual Studio Code, and so on. So this was just a little tour de Azure, nothing special, just to see how can you, just to familiarize ourselves what is Azure Portal and how it looked like. Thank you for watching. Azure World is a story in itself, but to understand Bicep, we need to get acquainted with some basic concepts. For those who know this concept, feel free to skip this lesson and go to the next one. The first thing I want to introduce is something called Azure Resource Manager, or ARM. So we have the definition of ARM. ARM is the deployment and management service for Azure. It provides a consistent way to create, update, and delete resources in your Azure subscription. It acts as the control plane. Every request that comes to Azure, it doesn't matter where it comes from, via portal, CLI, PowerShell, SDK, or templates, goes through ARM, or Azure Resource Manager. What are the benefits of using ARM templates, or ARMs, sorry? The first benefit is offer unified management layer for all Azure services. Role-based access control, so you can use a different roles. Resource grouping and tagging, and declarative deployments via templates. When we talk about a resource provider, some kind of definition will be that a resource provider is a service in Azure that supplies resources. Each provider offers a set of resource types. Some examples will be Microsoft.compute. It provides virtual machines or disk. Microsoft.storage provides storage accounts or blobs. Microsoft.networks provide virtual networks, load balancers, and you can ask yourself how it works. So when you deploy something in Azure, ARM communicates with the appropriate resource provider to create that resource. Simple as that. And of course, when we talk about templates, let's know what are templates. Some kind of definition for templates will be that templates are JSON or JavaScript object notation files or Bicep, which compiles to JSON, that define the infrastructure you want to deploy in Azure. Structure of these templates is that they describe resources, parameters, variables, and outputs. Usage is declarative, so you state what you want, not how to build it. It is repeatable, so the same template, as already mentioned, can be deployed in identical environments multiple times. And it is version controlled. It means that templates can be stored in GitHub or other repos. As you can see in our example, this is some kind of flow. First, we have a template that can be in JSON or Bicep. It defines infrastructure in a declarative file. So let me just grab my pen. Here it is. And as already mentioned, we are defining our infrastructure in our declarative file, in our Visual Studio Code. Then we have our Azure Resource Manager. The template is sent to Azure Resource Manager, which acts as a central orchestrator. Also, we have resource providers, as you can see. Then ARM here communicates with the correct provider. For example, Microsoft Compute, Microsoft.storage, or Microsoft Network. And finally, of course, Microsoft Compute is for VM, storage is for storage services, network is for network. For networking, of course. And finally, here in these resources, the provider creates or updates the actual resource in our Azure subscription. And that's the whole progress. Just to repeat this, to be clear. First, we are defining our infrastructure in a declarative file. This is our template, JSON or Bicep. Then we have our ARM. This template is sent to our ARM, which acts as a central orchestrator. Then ARM communicates with correct provider. As you can see, this is example of providers. And finally, that provider creates or updates the actual resource in our Azure subscription. And that's the whole thing about ARM resource providers and templates. Now it's time to know what is an Azure resource. An Azure resource is any manageable item that you can create, configure, and use within Microsoft Azure. Think of it as the fundamental building block of everything you deploy in the cloud. Some examples of our resources is, for example, compute. You can build virtual machines, app services, functions. Then we have storage. You can build storage accounts, blob containers, or disk. Networking. You can create virtual machines, virtual networks, load balancers, VPN gateways, databases like Azure SQL database or Cosmos DB. Then we have security identity for key vault, for example, and Microsoft Entra ID. Some key characteristics for Azure resources is that a resource group membership. Every resource that we create belongs to a resource group, which act as a logical container. Then we have already mentioned resource provider dependency. Each resource is created through a resource provider like Microsoft.compute for VMs, Microsoft.storage for storage accounts. And we have lifecycle management. Resources can be created, updated, deleted, or moved between groups or subscriptions. So lifecycle management of your resource is the time that you create and delete that item or resource. So that is lifecycle management. And finally, all resources that we create in our environment has a unique ID or resource ID within Azure, so it has unique identification. And that's it. That is the simplest way to explain what is an Azure resource. Let's hop to our portal and create our first Azure resource in our portal. So once again, we are in our Azure portal, and now it's time to see how can we create our first Azure resource. For this exercise, I decided to create a simple storage account. You can simply type storage account in your search bar, click on storage account, and you will be able to create a storage account, of course, from the wizard. Or you can go here, click on create resource, and find storage account right from here. Or you can simply go to all resources and find storage account, or click from these other two options from your favorites or from most used services. I will click on this icon, and we are in our storage center. As you can see, I will hit on create, and I will not use my MCT subscription. I will use my personal subscription. And let me first create a resource group. As we already know, every resource must belong to a resource group, which simply acts as a logical container. So I will use a simple terms. This will be RG1. Of course, when you work in some production environment or in your company, then the naming convention must be the right for this resource group. For example, this will be RG dash dev for development dash East US for the name of your region, and so on. But for the simplicity of our course, I will use RG1. Then the next thing we need to do is to add our storage account name. Of course, if you see these red stars, it means that these fields are you must fill this. Fields. Then when you add your name for the storage account, it must be unique. So let's find some unique name. For example, AZST account. Let me add some combination of random numbers, and let me see, it is unique. And finally, if I hit on this, hover my mouse on this little balloon, you can see a simple explanation. Azure region is, we already know what is Azure region, but here you must define where do you want to, in which region do you want to place your resource. Of course, as you can see, not all storage accounts configurations are available in all regions, so it really depends of the region. It depends of price, latency, how many data centers it is, or AZ or availability zone in that region. Of course, the most common used region is East US, for example. But sometimes East US do not have enough capacity for all these resources. So you must choose a different region. Of course, sometimes it really depends on quotas in your subscription. If you have you have some capacity that is reserved for your account, and if you go beyond that reserved capacity, then it will show you an error. Of course, I will choose North Europe because I use East US and North Europe most in my labs. Then this is an optional. You can choose your preferred storage type. I will choose my Azure Blob Data Storage or Azure Data Lake Storage Gen 2. Then it is optional. I can choose, for example, cloud native primary workload. I will choose performance is standard. I will choose my standard. And for the redundancy, I will choose my locally redundant storage. Finally, as you can see, Azure automatically recommends what is the best redundancy and performance for our cloud native primary workload. We can choose, for example, big data analytics and so on. It really doesn't matter what, because for this demonstration, because this is just a simple storage account, I won't get much in details, but remember that you must add your subscription, resource group, storage account name, region, performance, and redundancy. Let me go to advanced networking, encryption, tags, review and create, and finally Azure is running validation to check if everything is correct. And finally our validation is passed, and we will click on create. We are initializing our deployment. As you can see, deployment is in progress, and that's it. We are now using our ARM template to deploy this resource. As you can see, if I click on template, you can check our templates, and if we click on parameters, you can check our parameters. Our parameters is location North Europe. We have our name of storage account, standard ZRS, and storage v2. Of course, if I go to overview, you will get a notification that our storage account is created or deployed and it succeeded. This green mark knows it that our deployment is succeeded. Let's go inside our resource, and finally this is how can you create your resource. This is just a simple storage account. This storage account is general purpose version 2, and in this general purpose version 2 we have our containers, file shares, queues, tables. Just once again to remind you, if you want to learn more about storage accounts and the Azure itself, just go to my channel. There is a free AZ900 course with more than 20 hours with explanation and theory, and the good part of that course is related to our storage account. So this is how you create our first resource from Azure portal. Now that you know how to create a resource from Azure portal, let's create our Bicep environment and start working and create resources. If I go to my learn.microsoft.com Bicep install, here you can see various options. How can you prepare your environment working with Bicep file? First, you can deploy Visual Studio Code and Bicep extension. You can deploy automatic Visual Studio Code and Bicep extension. You can download Azure CLI, Azure PowerShell, Visual Studio Code and Bicep extension, and so on. And here you can see all explanations. But first, let's go to this link to Visual Studio Code, and I will download our Visual Studio Code for x64, of course, to my laptop, because I don't have Visual Studio Code installed. And let me just remove this. And first I will install Visual Studio Code. Let me accept my agreement. Let's click on next, next, next. I will create a desktop icon. Let's click on next, install. As you can see, this is a simple and straightforward installation. And after some time, we will be able to run our Visual Studio Code. And that's it. Let's click on finish. And our Visual Studio Code is automatically started. As you can see, let me just wait a little bit, and that's it. This is the latest version. After these welcome messages, we can simply go back to our Bicep, and as you can see, after that we need to install Bicep extension for Visual Studio Code. And let me just go to my Visual Studio Code, go to our extension, I will find Bicep, and that's it. This is our Bicep file. Let's click on install. We are installing our Bicep for Visual Code extension. It is installed, as you can see. Finally, maybe later, of course, finally I will go back to my Visual Studio Code, to our learn.microsoft.com, and finally we will download our Azure CLI, because I want to download this. Let's use our Microsoft installer, latest. Let me click on download. I have a fresh copy of Windows, of course, and I want to install my Azure CLI. I didn't install anything for now. We are using Azure CLI 2.83.0 x64, the official latest version of Azure CLI. Let me just once again go to this file, and we will accept the terms in the license agreement. Let's hit on install. Once again, yes. And just like that, we installed our Microsoft Azure CLI. And before we start to create some basic files, we will once again remind ourselves what is a Bicep file. But first, let's click on finished. Let me expand this. I will now go to my Visual Studio Code, and if I go to my File Explorer, let me go to C drive, and here I will create a new folder. This folder will be Bicep 1, and this will be our main Bicep. Let's go to File, Open Folder. Let me go to my C drive, and finally, if I click on here, select folder. Now this is the default folder. Yes, I trust the authors. This is the default folder for all my files in this part of this course. So this is how can you set up your Bicep environment. It's really easy and nothing complicated. A Bicep template is a file written in the Bicep language that define Azure resources you want to deploy. It's essentially the infrastructure as a code blueprint for Azure, but expressed in Bicep clean, concise syntax instead of verbose JSON. So let's take what are the key points once again of our Bicep template. You, as a person, describe what resources you want, for example, VMs, storage accounts, network, not how to build them. It compiles to ARM JSON. A Bicep template is automatically converted into an Azure Resource Manager or ARM template behind the scene. It is reusable, so the same template can be deployed multiple times to create consistent environments. Parameterization. You can add parameters and variables to make templates flexible, like different VM sizes or regions. And what are the outputs? Templates can return values like resource IDs or connection strings after deployment. A Bicep template is the blueprint for Azure infrastructure written in a simplified language that makes cloud deployment faster, cleaner, and more reliable. As you can see, this is just a simple example of our storage account. It's nothing special, just a simple resource with name of the storage account, the provider, API version, with the name, location, what kind of the storage account, SKU, and the name of this SKU. All that we learned now will be applied when we start working with the Bicep file itself, or the files. For now, let's stay on the theoretical part and slowly move onto the practical part of this course. But before that, let's jump over to the Azure portal one more time and see something else interesting about Bicep. Well, there is something interesting about Bicep. If you go to our storage account, if you remember, in some of the previous chapters, I created this storage account and deploy this first resource from our Azure portal. As you can see, there is nothing special here. But if I go in the automation blade and go to export template, you can see that you can export this template for this storage account in ARM template, Bicep, or Terraform, as you can see. And you can download this, copy this, or deploy again. And there is a warning here, message to export a selection of these resources. Select resources from the overview view and select the export template for the option from the toolbar. Let's click on this option, and here you can check this, and you can go here and export template as ARM, Bicep, or Terraform. For the moment, I will go back to our export template just to show you how this ARM template looks like. We have schema, as you can see. We have parameters. Here there is some parameters for our storage account, name, what is the default value, and type. It's string. We don't have any variables. We have our resources. What type of this resource is? As you can see, Microsoft.storage/storage accounts. This is our resource provider. API version, the name. We are using parameters, location, SKU. In that SKU, we have object. For example, this is called object. What kind of the storage account is, and what are the properties of this storage account, as you can see. And the whole script of this, or file for this template for this storage account, is 134 lines, of course, with parameters. If I go, for example, in Bicep option, we need to wait to our Bicep to be load up, and here we have our parameters, we have our resource, as you can see, and all that from our R template translated to our bicep, and all that is consist in, let me see, 110 lines, which is, you must admit, short, not much short, but it's short, of course. And you can see all of this in Terraform. If you want to learn more about Terraform, click here on this link, and here is our Terraform. As you can see, this is our block, and Terraform consists of 65 lines. So it really depends of what are you going to use. When you talk about Terraform, if you remember that table comparison between Bicep and Terraform, here I talked about resource provided for different cloud services, for different cloud providers, sorry. This is Azure RM, as you can see, and this is the version. So if you're using Terraform, you must pay attention to this source and version, because Terraform is often update their source and version of their product. Of course, if you want to learn more about Terraform, go find some Terraform course, because this is not course about Terraform, this is course for Bicep. And now let me click on download this file, and just like that we have our main Bicep file. I will hit on open file. This time I will choose Notepad. I can choose my Visual Studio Code to open this, but I will choose Notepad and click on just one, and here it is. We have our storage account on our desktop, and that's it. Now we can copy this and go inside our Visual Studio Code, change the name of this storage account, for example, change the location and so on and so forth, but I won't do it for now. As you can see, this is interesting that I want to show you about Bicep, ARM template and Terraform in Azure. So you can export any template of almost any resource that you provide or create in your Azure portal. And this is how Bicep file for this storage account looks like. So that's the end of this lesson, and I hope this was helpful. Let's continue to learn more about Bicep. Welcome back again. As you can see, I'm in my Visual Studio Code, and now it's time to see how can we create our first Bicep file. This will be a very simple file. I will try to create a file that will deploy our resource group without any resource, just a simple resource group. As you can see, I already defined my folder, and I will click on this link to add a new file. I will add simple name. This will be rg.bicep. When you type bicep and hit on enter, you will get this small icon which refers to Bicep. And here we have an option to add our code or simply start to type. When you start to type your code, as I already mentioned, and for people who are working in Visual Studio Code, know that Visual Studio Code contains something called IntelliSense. So this is a great option for you, for your code to be automatically how to say, provide with some different parameters. Of course, we will see all this when we start working with our file. If I go to our main.bicep, you can see that this is our bicep from previous lesson. This bicep contains our storage account parameters and all other informations. This is storage account. This is a file that we download, template that we downloaded from our Azure portal. And here in the new notepad, I prepared a simple file that will, and now I will copy this file just to show you how it looks like. As you can see, there is a different colors, of course, and I will now try to explain how to create this manually. First, you will type a resource, and if I click on resource, this is how IntelliSense work. Then I will give just a symbolic name. Let me add just another RG, and then we will add our provider. Let me find Microsoft Resources. We need to type Microsoft dot capital R resources, then slash, we need to find our resource group, and finally we can hit here and add the last date for this API. Of course, then we'll hit on enter, hit on space, hit on equal, and add our curly brackets, and as you can see, it will automatically add the location, but I won't use this location. I simply want to go to the next line and add the name for our resource group. This name of our resource group will be RG2. Exactly, let's hit on enter. Exactly the same parameter that we use here, and we will add East US, and that's it. This is the whole script for our resource group. I will now simply delete this, and there is a good option. If you type target scope, let's type target scope. As you can see, let's hit on tab, and it is automatically added. And now I will now choose our target scope. As you can see, just like here, equal, and this will be subscription. You can choose between different target scopes. You have management groups, subscription, and resource group. So let me just check if we are doing, this is without S, and subscription. And that's it. And the next thing we must is to save this file. Let me click on save, and this file is saved. You must save your file every time that you want to run this operation. And now let me go here, and with our right click we can deploy or try to deploy our Bicep file. Let's click on here. We must allow this. As you can see, our output is here. I will choose my account. This is our name for our deployment. Let's use RG2, for example. My subscription. And let's choose our location. Our location is East US. Let's find our East US, and parameter file will be none. As you can see, we are waiting for our deployment to be complete, and as you can see, deployment succeeded for our resource group. If you go to our portal, this is our storage account. Let me go to my Microsoft Azure, and let me click on resource group. As you can see, we have our RG2 resource group located in East US using subscription. And that's it. That's the whole point of how can you deploy your first resource to a resource group. I will now delete the both of my resource group just to simplify this. We will of course do a lot of complex deployments, but for now let me delete all resources that we have in this account, in this subscription of course, and in the next chapter we will continue learning about Bicep. But once again I want to stop here and I want to talk about data types in Bicep. This is very important section. So in computer science and computer programming, a data type, or simply type, is just a collection or grouping of data values, usually specified by a set of possible values, a set of allowed operations on these values, and or a representation of these values as machine types. A data type specification in a program constrains the possible values that an expression, such as a variable or a function call, might take. A data type may be specified for many reasons, like similarity, convenience, or to focus the attention. It is frequently a matter of good organization that aids the understanding of complex definitions. Almost all programming languages explicitly include the notion of data type, though the possible data type are often restricted by consideration or simplicity, computability, or regularity. An explicit data type declaration typically allows the compiler to choose an efficient machine representation, but the conceptual organization offered by data type should not be discounted. Well, if we go to our slide, on the next slide, we have some data type in Bicep. I will just present the core data types, like strings, for example. Just let me grab my pen and I will explain this table. As you can see, we have the first data type in our Bicep is string. This is a text value, and this is an example. For example, when you need to add in your script region, you will type this kind of data type. The second one is integer. This is integer values. It represents a number, as you can see, and we have in our example it's number 3, for example. Then we have Boolean values. It can be true or false. We have arrays. This is just a logical values. This is array is Boolean is logical values, so we have true or false. Array is an ordered list of values like A, B, C. For example, you can use brackets and add 2 regions, for example. Then we have objects. This is a key value pair. It represents by curly brackets, and you can see that we have name and size for our machine. Objects are very common when you have multiple values to add to your expression in your file. We have null. This is explicitly represent no value, so it represents with null, as you can see. And then we have some special construct. For example, we have resource define an Azure resource, and this is the example. As you can see, it defines an Azure resource, as I already told you. As you can see, we have our provider, Microsoft. This is, for example, a resource VM, Microsoft.compute/virtual machines at, and we have this API, and so on. And then we have module. This is another important Bicep file. For example, module we will learn more about modules, but for now just remember that it imports another bicep file. I don't want to confuse you right now. Later in this course we will talk about module. And then we have parameters. As you can see, this is just an input parameter for deployment. Parameters passed at deployment time, and this is how it looks in our bicep file. So we have parameter, for example location, and then we add a string east-us, as you can see, and we have something called variable. Variables is calculated inside the file output, and this is how can you add your variable. It's represent var VM name, for example, and then add simple string. Of course, there is an output value, as you can see, and this is just a value returned after our deployment, and this is how value of output looks like, some kind of example. But before we continue, I want just to remind you that bicep is strongly typed. Mismatched types cause completion errors. Parameters have different values and constraints, like allowed list. Objects and arrays can be nested for complex structures. So more about data types and all these core data types and special constructs we will see in examples when we start to work and create our bicep file. Well, now it's time to see how can we deploy a storage account with our bicep. But first, the good practice is to represent all these services first in theoretical part, then I will show you how can you create these individual resources from Azure portal, and then we will type our bicep file and of course work with our biceps. But first we need to see what is Azure storage account. But I won't create new Azure storage, because when we deployed our first or create our first resource from Azure portal, it was Azure storage account, so you know how to create a storage account. Now it's time to learn what is storage account and how can we create a bicep file. First, an Azure storage account is the fundamental container for all your Azure storage data. It provides a unique namespace in Azure that can store different types of objects, of data objects. First, we have blobs. Blob is for unstructured data like documents, images, and video files or videos. Files, it is a fully managed file share accessible via SMB or NFS. We have queues. This is for reliable messaging between application components. And we have tables for NoSQL key value storage. Then we have type of the storage account. The first one and the most used is general purpose version 2. It supports all storage services with the latest features. So in general purpose version 2 we have blobs, files, queues and tables. Then we have blob storage account. It is optimized for blob workloads. We have file storage accounts optimized for file shares, and we have premium storage accounts for low latency, high performance workloads. General purpose version 2 work on HDD, and premium storage accounts works on SDD drives. So let's hop to our Visual Studio Code and see how can we create a bicep file based on Azure storage account. Here we are in our Visual Studio Code, and the first thing I want to do is to create a new file. I will go to our bicep folder, click on new file, and this name for this file will be storage account, for example. Let me add just something like this, dot bicep, and here it is. We have our new file, and now I will start working with our bicep file. The first thing I want to do is to type resource, as you can see, and now if I, for example, click on tab or on my keyboard, it will finish this first resource word. Then I will type the symbolic name of my storage account. This name must be unique, and sorry, it not must be unique, but I will add, for example, CTACC, and then we need to specify our provider. This will be Microsoft.storage, and then we will type slash. Here it is, storage account, as you can see, and we will add the latest version of our API. Then we need to add equal, and finally we will use our curly brackets, hit on enter, and then we need to specify a name for our storage account, and then this name must be unique. As you can see, there is a predictive option, and I will hit again this storage account. Let me add some unique name. For example, this will be our name. I hope it is unique. As you can see, we don't have to put any symbol here, just simply click on enter. Then we need to add our location. I will add, for example, North Europe, but for this exercise I will add, for example, East US. Again, we need to hit on enter, and then we need to specify what kind of storage we want to add. This will be storage version 2, because this is just a simple general purpose storage. And if I hit on enter again, we need to add our SKU. What is the type of storage account? It is standard, premium, and so on. So we need to type SKU, and I will once again hit my curly brackets, and here it is. We need to specify our name, and this will be standard, as you can see, LRS, and that's it. That's the whole script for our storage account. And now I want to save this file. Let me click on save. And the good thing about our Bicep files is that we can deploy this. I already showed you how, and you can deploy right from here. The only thing you need to do is to log into your storage account or to your Azure account. But I want to work from my portal using, as you can see, my Cloud Shell. Let me go to my Cloud Shell. We are waiting to be connected. And we will switch to the PowerShell as soon as we connect to our terminal. Just need to be patient. I will switch to PowerShell. Yes, I want to confirm this. And right from here, we can run these commands. So first, as I already told you, if you want to work from Cloud Shell in your browser, choose PowerShell or Bash terminal. I want to run PowerShell, and this command, az group create --name rg1 --location North Europe. This command will create a new resource group. So I want to use East US, for example, for my resource group, and I will copy this command. Let's go step by step. So we are first creating our resource group. It was successfully created, as you can see. And the second thing I want to do is to deploy my bicep file, my bicep script. In this command, we will use az deployment group create -- resource group name. This is our name for our resource group that we created in first step. And then we need to add -- template -file and the name of our file. And this command will run all our bicep script. But first, we will main.bicep. We will add name of our file, of course. Let me just copy this command, paste it here, and I will simply choose my name. This is st_acc.bicep. Let me just add acc.bicep, and this is the command. But first, if I go to manage files, click on upload, we need to upload our script. Let me find on the C drive my bicep folder, and here I will add my script, and as you can see, we successfully uploaded our file. And then I will hit my enter, and as you can see, our bicep file deployment is starting, and very soon we will get confirmation in JSON file that is created successfully. In the meantime, let me just go to our Visual Studio Code, and if I hit our table, as you can see, this is our data types. So you can see that we are using strings, and that's it. We are just waiting for our deployment to be successfully created. Here it is. Provision succeeded. As you can see, this is our storage account, and now this is my subscription. This is the whole value. And if I now go to our resource group, let me just check on my resource group. In our resource manager, this is our resource group that we created, and this is our storage account. So if I go to our storage account, this is just a simple storage account, as you can see, located in East US, standard LRS, storage v2, provision state succeeded, and the date when we created this storage account. As you can see, nothing special, really easy, and I hope this was helpful. Let's go to another example. So in previous chapter or previous lesson, we learned how can we create our storage account via use of bicep file. But what if we need to deploy multiple resources with bicep? And when I say multiple, I mean, what if you have some need to provide more than one storage account? How can you do this? Do you want to, for example, copy this command and paste it here and just change the name? Well, it's not so good option. There is an option in bicep, of course, to use iteration. First, I will explain everything, don't worry. First, I will once again save this, and we will open our new file, and will be type something like multiple.bicep and hit on enter. As you can see, we have our new file. And then I will simply copy our storage account script from previous chapter. And when I say iteration, I mean when you use in bicep, iteration means creating multiple instances of a resource, module, or variable in a loop-like fashion. Instead of repeating the same resource block many times, you can use the keyword to iterate over a list or a range. The best practice is to use this option. When you use iteration, it is good to use for scalability and consistency. You can also keep arrays in parameters, so you can adjust your deployments without even editing this template. You can combine iteration with objects for complex configurations like multiple subnet with different prefixes. So here, as you can see, this is our storage account that we created in our previous chapter. Now I want to run a script, the same script, but this time we will use some different options. Here we will use, of course, we will use the same script here. After our first line, in our first line here, I want to add a new bracket, as you can see, and here I will use for option for I in range. As you can see, we can add right from here, and I want to create 3 storage account. I will add 3 and type on space, add number 3. So what did this mean? This means that every time that this bicep file start to run, they will create the first storage account. Then it will go back to the beginning of this first line and run it 3 more times, so we will have 3 storage account. As you can see, here is an explanation. You can run this range. You need to add your start index, this is our 0, and count integer, this is a value. Our data types integer, this is 3, so it represents the number of how many storage accounts do we want to create. And finally, we need to add semicolons here and type on enter again, and of course we need to close this with our brackets. And there is also one more thing that we need to do, and here, as I already mentioned, we need to specify the name. So I will add a $sign and add the value of I, because I represent iteration and it represents this range. For I, every time that this script runs again, the name must be different. So it will add, for example, 0 for first storage account, 1 for this storage account, and so on and so forth. And finally, I will now run this script. Let me just save this script by typing Ctrl S. Let's go to our portal. I will now run my command. Let me first copy this command az deployment group create template file. We will be change this name of our file because this is a multiple file. If you remember, we already have our resource group. Let me just change the name of this bicep file. This is multiple.bicep, but first we need to upload our script, and finally let's hit on enter to run our script. So just to remind you, we are deploying multiple resources. We want to create multiple storage accounts, and as you can see, it's running, and very soon we will get our confirmation that this deployment was successfully finished. After that, we will go to our resource group just to confirm that this deployment worked. And here it is, confirmation in JSON file. Provision state succeeded. Let me just minimize this. We will go to our resource group, and inside our resource group we have, just let me refresh this, we have our 3 storage account, as you can see, but the main difference between our first storage account which we created in the previous lesson, that we have now 3 storage accounts, and the prefix is, for the first one is 0, the second one is 1, and the third one is 2. This is how can you use our for I in range. This is loop-like fashion in Bicep. So that's it. Thank you for watching. An Azure Virtual Network, or VNet, is the fundamental building block for networking in Azure. It acts as your private network in the cloud, allowing Azure resources to securely communicate with each other, with the internet, and with on-premises networks. Key features of Azure Virtual Network is isolation and security. So VNets are logically isolated from other Azure networks, ensuring privacy, connectivity. It connects VMs, databases, and apps within the VNet, or link virtual networks together, like VNet peering. It has hybrid integration. Extend your on-premises network into Azure using VPN gateway or ExpressRoute. You can control or define your subnet, IP ranges, routing, and network security group. And it is very good for scalability. So VNets can span multiple availability zones and regions, supporting enterprise workloads. So you may ask yourself, why are we need to use VNets? You can use to replicate familiar on-premises networking concepts in the cloud. You can use it to build secure applications architectures where tiers like web, apps, databases are isolated in the subnets, so nobody from outside world, for example internet, can access to your database app or web app. Then you can use it to enable hybrid cloud scenarios like linking Azure with your data center. You can think of VNet as the foundational layer. Once that you created, you can deploy resources like VMs, storage, databases inside it and control how they communicate. Let's hop to Azure portal and see how can we create virtual network. The good thing about virtual networks is that this resource is free, so you can practice if you want. Let's click on this icon. We are in Network Foundation, and as you can see, we have virtual networks and the various options that you can choose from. But for now, we are interested in virtual network. Let me hit on create. When you hit create, you must fill this wizard with your project data. I will choose my Azure subscription. I will choose my existing resource group. You can create a new one if you want. We need to add a name for this VNet. For example, I will add just a simple name, VNet1, and it will be located in North Europe region. If I click on next in the security tab, you can add some more security services. This is all paid security services. As you can see, we have virtual network encryption. This enables network encryption to encrypt this traveling of our packets inside our virtual network. You can create something called Azure Bastion. This is also a paid service that provides secure remote desktop protocol or secure shell connectivity to our virtual machine without using these files. So within your browser, you can securely connect to your, for example, virtual machine. Then we have Azure Firewall. This is just a managed cloud-based network security service that protects our resources. And we have Azure DDoS protection. This is also a paid service that offers enhanced DDoS mitigation capability with adaptive tuning, attack notification, and telemetry to protect against DDoS attacks. I will leave everything as it is. Let's keep it simple. Let's go to next, and here we need to add or define our address space of our virtual networks. We have IPv version 4 and IPv version 6 address ranges. As you can see, there is also added subnet 10.0.0.0/16, and here we have our first subnet. This is our default subnet 10.0.0.0 10.0.255. So you have 256 address. This is the size of our subnet. If I click on this little pen, you can change various or edit this subnet. You have this subnet purpose. For some services in Azure, the services need to have their own subnet with this predefined name, like Azure Bastion, Azure Firewall, Firewall Management, Force Tunneling, Virtual Network Gateway, and Route Server. We will leave everything as it is, and here you can change this IPv address space. If you have, this is our starting, you can change the starting IP address, choose your size, as you can see, and so on and so forth. But I guess you are familiar with Azure VNet, with Azure and VNet. I will click on cancel and simply create this. We are not using tags this time, and simply create this virtual network. I will hit on create. So once again, if you want to learn more about VNets and go in depth, just search AZ900 in this channel and you will find it. And you will understand more about VNets. There I explain everything in great detail. And here it is. I will go to our resource and we have our address space. This is our VNet. We have our address space and we have our subnet that we specified when we create this VNet. Of course, there was 256, now it's 251 available IPs in this subnet because Azure has taken the first 4 and the last one in just to be able to work with this. Of course, let me now delete this complete VNet and we will create bicep file and try to deploy virtual network with automation. Let me hit on delete and that's it. Our virtual network is deleted. Let me just go to our resource group and here is just these 4 storage accounts that we already have. Welcome back, and I will try to create our VNet or virtual network with the use of Bicep. Let me create a new file. This file will be called vnet.bicep. In this file we will create a simple virtual network and we will use 2 subnets. For example, the first I want to type is resource. Then we need to add a symbolic name to our virtual networks. This time I'll use something like this network. And let's add our Microsoft.network/virtual network. The latest API equals our brackets. Let me add a name for this. This will be, for example, VNet1. Let's go on another line. We need to specify our location. Our location will be East US. Then we need to specify properties. Let me just open once again our address space. We will add this in the next line. Our address space will use once again address prefixes, and here we can send this to another line, and here we will use simple brackets, and we will add our address space. This will be 10.0.0.0.0/16. Finally, let's create our first subnet. Here in the subnet, we need to specify the name of our subnet. This can be our subnet 1. Then I will add properties. In the properties, we will again use our curly braces, and we need to add our address prefix. And this address prefix will be, for example, 10.0.0.0/24. Of course, I want to create another subnet, so I will copy this whole address here, add our subnet here. Let me just change this to subnet 2. Then in the properties, we need to specify our address prefix. It will be 10.0.0.1/24. Let me just save our script, and we can go to our Azure portal. Let me once again run our PowerShell. PowerShell or Cloud Shell. We will upload our script. This is a VNet script, and let me just change the name of our bicep file. This is VNet bicep file, and I will hit on enter. So we are trying to create virtual networks with two subnets that we specified in the previous chapter, and it is running, and I guess it will be okay with this deployment. Here it is. We are getting the confirmation that everything is succeed. Let's go to our resource group, and inside our RG1 we have our VNet. If I go inside that VNet, we have, as you can see, North Europe location, two subnets. This is our address space. If you go inside our address space, you can see this is our address space, and in the subnets we have two subnets that we specified in our bicep file. So that's it. Thank you for watching, and let's go to another lecture. Now that we know how can we create our VNet and with two subnets, I want to introduce you to the functions in our bicep file. Well, I will use CIDR range function with bicep. It's very convenient, as you will see, of course. But first, I would like to introduce you with the CIDR range. It refers the way IP address blocks and represents using classless interdomain routing or CIDR notation. It's commonly used in networking, including Azure VNets and subnets, to define how many IP addresses are available in a given block. For example, IP address or the starting point of IP address can be 10.0.0.0 or 192.168.0.0. Then we have something called prefix length. This is the number of bits used for the network portion. For example, /24. In Azure, when you create a virtual network or VNet, you must specify a side range like 10.0.0.16, as we already know, and subnets inside that VNet are defined with smaller side ranges like 10.0.1./24. CIDR ensure that IP and RES do not overlap and the resources can communicate properly. So this is some basic knowledge about our side range. But first, I want to create a new file. This file will be named cider.bicep, and I will simply copy our script from our VNet folder from the previous lesson and paste it here. And now I want to use this function cider. We will leave the first block of our virtual network just like it is. I will delete our second subnet and let me just delete our subnet number 2. And now in the subnet option I want to use once again loop like. We will add for I. We already know how to work with this iteration option in range. Then we need to specify it from 1 to 4. I want to create a 4 subnets and of course semicolon. We need to open a new bracket and that's it. We now have the name of our subnet and in the subnet name I will add our $, of course, and use our curly brackets to add I. And finally, this is our name, this is our properties, address prefix. We need to specify our cider subnet. So here I will add our cider subnet, so we can use this subnet. Inside that subnet I will copy our, let me just copy this subnet here, and finally this will be /16 because we are adding our address prefix here. Then I will add our 24. This represents our side range and we need to add our I. And here, of course, we will simply add this here and that's it. Let me save this. You can click on Ctrl S or simply go here and type here. We will now go to our Azure portal. Let me run once again our Cloud Shell. We will upload this is our cider bicep. Let me just, if you move your arrow up, you will have the latest command. We just need to provide the correct name for our file and let me hit on enter. So we are using AZ group deployment easy deployment group create, and that's it. This is how can you create your use function in your subnet. For creating multiple subnet, of course, in the bicep file. It's not that complicated. As you can see, we are specified our for I in range from 1 to 4. We want to create 4 subnets, and then we specify the name of our subnet, of course, with our $sign. In the properties, we added our address prefix. In the address prefix, we use our CIDR subnet and add our prefix, add our number, CIDR number. This is 24 because all our subnets will have CIDR range of 24, and the I represent the subnet name. As you can see, our provision is succeeded. Let me just minimize this. If I go to our resource group, you can see that we have our VNet 1 here, and if I go to our subnet, if I go to our VNet, of course we have our address space. If I go to subnet, we have our 4 subnets that we specified. As you can see, our IPv4 subnet is 10.0.1, 10.0.2, 10.0.3, and 10.0.4. All is /24. So once again, just to remind you, we are using for each loop. This will define the 4 subnet in our VNet with a different name, and this time we specified our CIDR prefix. That's it. Thank you for watching. Well, in the previous chapters or examples, we really learned a lot, but now it's time to introduce you with a new term, and that is variable. So what is a variable in Bicep? In Bicep, a variable, or simply var, is a named value that you defined once and then reuse throughout your template. It really helps your code avoid repetition and make deployments more maintainable. The key points of using variable, you can see here that you can declare with the var keyword. You can store strings, integers, arrays, objects, or even expressions. You can evaluate at compile time before deployment. It is useful for values that are reused multiple times or derived from parameters. The best practice to use variable in Biceps is they can use variables for divide values like names or calculated strings. You can keep parameters for user input and variables for internal logic, for example. You can avoid hard coding values directly in resources. Variables make templates cleaner, and that's it. This is our variable. Let's hop to our Visual Studio Code and learn more about variables. And once again, we are in our Visual Studio Code. I will create a new file. This will be called variable.bicep. I would like to use our previous CIDR example, and this time let me go to variable bicep and I will copy our code from previous example. But first, let me go to our resource group. In our RG1, I will delete our VNet. Let me just delete this single resource, type delete, click on delete, and as you can see, we are executing delete command. Here, very soon, we will be without our VNet, and let me minimize this. And here, I would like to show you how can you use your variable. Instead of using these options like VNet, these strings like location, you can use variable. Let me just add a new line. I will type var, for example. As you can see, the Visual Studio Codes automatically recognize that it is variable, and I will like to add network name. variable, and let me hit on equal, and we will add, for example, vnet. This is our value. Then in the next line I will type new variable. This one be location. I will add equal, and here we will add our North Europe location, and let me add another variable. This will be network address prefix, and I will type once again equal, and here we can add our 10.0.0.0/16. And here in the vnet, in our resource, I will simply use, let me delete this, and if I start to type network, you can see that we can add our network name, which is referred from here. So all the value, instead of hard coding, you will get from this variable. Of course, the same thing we can do for our location. I will simply type location, hit on enter, and let me just use network address prefix. I will delete this, and we will use our variable, and that's it. This is how can you add your variable. Let me save this file, click on Ctrl S or go to file, and that's it. And now we are ready to go back to our, as you can see, we don't have any vnet. Let me open my Cloud Shell. We will now click on manage, upload. We will upload our variable file, bicep file, and simply change the name of our file and hit on enter. So with the help of variables, we will create exactly the same. Let me just, I made a mistake in our file. Okay, North. Let me just change the location name. I will add East US. I used to work with North Europe, and that is my main location when I creating resources. Of course, let's use East US. I will now simply save this, and let's go back to our Cloud Shell, and once again let me simply run this again. As you can see, this will now run our script. Of course, we need to upload our new file. It is good to see that nothing is perfect and nobody is perfect, of course, and troubleshooting is always good. So as you can see, even nobody knows everything. Everybody made mistakes, of course. So sometimes it's good to make a mistake. And we are now deploying our group. As you can see, we simply changed our region and upload a new file, and here it is. Our provision state is succeeded. Let me simply refresh our resource group, and as you can see, we have our vnet. If I go inside our vnet, it is exactly the same address space. In the subnets, we can see that we have our 4 subnets, just like in previous with previous file when we used function, cider subnet function, of course, and now with the help of variables, we created exactly the same resources, but with the use of the variables. I hope this was helpful, and now you know how to use variables. Now that you know how can we use variables, it's time to meet with a new term, and that is parameters in Bicep. In Bicep, a parameter, or simply param, is a value that you defined in your template that can be supplied at deployment time. Parameters make your template flexible and reusable. Because of, instead of hard coding values, you allow users or deployment scripts to pass them in. Well, some of the key points of parameters are you can declare, it is declared with param keyword. You can have a type, different data types like string, integers, boolean, arrays, objects. It includes default values and constraints like allowed list or min length, for example, which is minimum length. Values are provided when you run the deployment via command line portal or pipeline. So when you run your script in, for example, Cloud Shell, you must add -- parameter and that file. There is some different from variables, parameters. Parameters values provided at deployment time. This is just an external input, and variables is values are calculated inside the template. So this is something called internal logic. This is the difference from variables. Before we deploy our resource using parameters, let's once again see our table and see what is the difference between parameters and values. Let me just grab my pen and I will explain the differences. Here, the first column is for parameters and the second one is for variables. When you use parameters, the purpose of using parameters is that they accept input values at the deployment time. Variables are stored, calculated, reusable values inside the template. So this is why I already said it's internal logic and parameters are external input. It is defined by using deployment script and template author. Flexibility, you can make templates reusable across environments. If you use parameters and with variables, it simplifies code and avoid repetition, as we already saw in the previous chapter. You can have defined values, like can have defined constraints, like allowed, minimum length, etc. With variables, you can derive from parameters or other expression. When you talk about evaluation, it is supplied at deployment time and variables are evaluated at compile time. Some kind of example, as you can see, parameters location string equals is2s, for example, and for variables we already know that you can use var storage name equal $ location storage, as you can see, and use case you can choose region, VM size, and instance count with the parameters, and with variables you can build resource name, tags, or derived values. So this is the main difference between parameters and variables. Let's hop to our Visual Studio Code and see how can we deploy our resource using simple parameter file. And let's see how can we create our parameters. First, as you already know, we will create a new file. This will be parameters bicep, and I will go to our variable bicep file, copy exactly the same script in our parameters.bicep. Let me paste it here, and now we will use our first parameter. First, I will like to delete our variable for location, and I will simply type 2 times on my enter, and add our first parameter. If you want to use parameter, simply type param and click on enter. Here we need to add parameter for our location, so we will use our location. It is a string, as you can see, equals, and we need to add our East US, as you can see. Of course, I will now go to my portal and delete again our VNet1, just to be sure, because I want to run this script once again. Let me type delete, and with the help of this script we will get exactly the same result, just like with variables, and when we use our CIDR subnet function. So we'll need to wait to this. Here it is. We don't have any resources based on VNet. And finally, I will now go back to our script. Let me just show you another thing. If I want to add a description for parameters, I can use here and simply add a description. Here I can add something like, please specify location for the resource. It is good that you can add your description here, because if you're working in different teams, as you can see, we can add a different actions here, and that's it. And that's it. This is how can you set up your parameters, and this is a good practice where we are using parameters and variables at the same time. The only thing, as you can see, we don't even have to change this location option, because now location we are getting from our parameters, and name and network address prefix we are getting for these variables. As you can see, if you hover your mouse, this is location is a string, and this is parameters, as you can see. Now I want to save this file, and I want to run this script. Just we don't have any VNet. The first thing we need to do is to upload our file. Exactly the same thing, but this time we are using our parameter bicep, and this time we need to change our bicep name. This is parameters, and let me try to run this deployment. And we are still waiting for this to be provisioned. So I guess we have some problem with Cloud Shell. Never mind, I will simply run once again this Cloud Shell, and we will be use our let me just copy this command from our notepad just to make our life easier. First we will upload our parameters file. When you work with Cloud Shell or cloud, sometimes it's really painful, but let me just add the name of our bicep file, and let me try to run this again. Here it is, it's starting. So if you have some problem with Cloud Shell, it can be due to inactivity. Just simply press on X, exit from here, and run this Cloud Shell again, and upload your file, bicep file, and run this AZ deployment group create. We have a resource group and template file. Of course, I hope that we are getting our VNet with 4 subnets. This time it succeeded, as you can see. And once again, I will refresh our, let me try again. We are still waiting for our VNet to be shown here, and after some time we will be able to see our VNet. Here it is, we have our VNet here, and if I go to our subnet, we have our 4 subnet using parameters and variables. If I once again go to our resource group, you can see that we have our VNet here. And that's it. This is how can you work with parameters, how can you add your description to your parameters, and how can you combine parameters and variables in your, and of course, for loop, iteration, and CIDR subnet function. Thank you for watching. In Azure, a public IP address is a resource that allows Azure services like virtual machines, load balancers, application gateways, etc. to be accessible from the internet. It's essentially the front door for external communication. Let's learn some key characteristics about public IP addresses. It has unique internet address. It identifies your resource to external clients. The address can be static or dynamic. When you have static, the IP stays the same. It is useful for DNS records or long-term access. If you choose dynamic, the IP can change when the resource is stopped or deallocated. We have 2 types of IP addresses. First is IPv version 4 and the second one is IPv version 6. Both supports address families. It can be associated directly with the VM's network interface card or with services like load balancers. Of course, when we talk about security, it's typically paired with network security group or NSG or firewalls to control inbound and outbound traffic. Some use cases of public IP address: if you want to expose a web server, virtual machine to the internet, you can use public IP address. You can assign a public IP address to an Azure load balancer for distributing traffic, and it provides a stable endpoint for hybrid connectivity, for example, for VPN and express routes. Let's hop to our portal and see how can we create a public IP address. The great thing about Azure is that all aspects, for example, for virtual machine, we will talk about virtual machine later in this course, is that all dependencies need to work with this resource is a separate resource, and one of them is network public IP address. You can create your own public IP address. If I go to our marketplace, and here I can type, for example, public IP address, click on this. I will click on this link, and we will choose our public IP address with Microsoft as a publisher. I will hit on create. So for example, you can create a virtual machine without public IP address, and then you can, after that deployment, you can create a public IP address and associate that public IP address to a network interface card of that VM. I will choose my existing resource group. This is RG1. I will choose my subscription, my private subscription. Let me choose my region as East US. Name will be public IP address. For example, something like this. and you can choose a version, IPv version 4 or IPv version 5. Let's go to next. You can choose DDoS protection. We will use protection type is network. It inherits DDoS protection from your virtual network. I don't want to use tags. I don't want to use nothing. Validation is passed. Let's hit on create and we are creating a public IP address. Public IP address is already here and I will hit on go to resource and that's it. This is how can you create a public IP address. As you can see, this is our IP address 20.102.20.247 and this is the public IP address that we can use to route, for example, in or out from this virtual machine. As you can see, nothing special here. You can click on associate and here you can choose to associate to load balancer or network interface. We don't have any load balancers for now, so we can associate and we have some different configuration properties and that's it. I will now go to my resource group and delete this public IP address because I want to create a new public IP address with the help of bicep file. Let me hit on delete. We need to run delete to confirm this deletion and let's hit on delete. I hope that you like this kind of communication. First we are learning theoretical part, then I'm showing you how can you create these resources from Azure portal, and then we will see how can we work with our bicep file. Here it is. We don't have this resource anymore. Let me hop to our Visual Studio Code and we will create a new file. And we will create our new file. This will be public IP.bicep and here we need to add this will be just a simple resource. I will type resource public IP and we need to add our Microsoft dot network slash public IP addresses and that's it. Then we will hit on equal. We will add a name for our public IP address. This will be public IP, for example, something like this. In the next line I will add my location and this time I can use something like resource group, as you can see, and we can pass location and that's it. The location will be, you can use another option. Then we need to add our SKU name. This will be, we can use the same line if you want. We can use standard and finally in the properties we can add something like public IP allocation method and this method will be static and that's it. That's the whole point. As you can see, we can type even in the same line everything. I will now save this file. Let's go to our Cloud Shell and first we will of course upload our file. This is public IP address. We will run our file, but let's change the name of our bicep file. This is public IP bicep. Let's hit on enter and I hope that we will be able to deploy our public IP. And after some time, we will get our notification that this provision state is succeeded, and we will then continue with the next bicep file. Here it is, provision state is succeeded. If we go and refresh our resource group after some time, as you can see, we have our public IP address exactly the same, but with different, as you can see, public IP address, and that's it. Let's go to another lesson. Well, if you want to create a deployment, we will first need to create something called network interface card. Let me just show you how can you create this network interface card from your portal. We will once again go to our marketplace, and let me simply type NIC. Here it is. We will choose Microsoft or Azure services only. Let me just type network interface card. Here it is. I will choose my subscription, choose my resource group, add a name for this NIC, choose my region, choose my virtual network. This is our virtual network. This is our subnet. I can choose one of, we will choose our VNet 1, and we can choose our one of subnet that we have here, and I will choose this subnet, for example. We can choose IP version 4, or you can choose both of them, and static or dynamic public IP address. You can go to tags, go to review and create, and after validation is passed, you can create your network interface. So we're waiting for this deployment to be completed, and finally our NIC is created. Let's go inside our resource. As you can see, we have only private IP address, but we can add or associate our public IP address that we created in the previous chapter to this network interface card. But I won't do that. I want to go to my resource group and delete my network interface card, and then let me just type delete. So if you heard some strange noises, there was some construction work in my neighborhood, so I apologize for that, but I can do nothing about that. So we are running Bicep, and that's it. I will now go to my Visual Studio Code and show you how can we create NIC, but using multiple resources. Let's create our network interface card. First, I will create, as you already know, new file. This will be nic.bicep, and here we can type our resource. We need to add our symbolic name. Let me add something like NIC, and then we will add Microsoft.network. / network interfaces equal, we will provide the name for our NIC. This will be, for example, NIC1. In the next line, we need to add our location. This location will be based on resource group dot location. Then we need to add our properties. As you can see, IntelliSense work perfect Then I will use our square brackets, but we need to define our IP configuration. Here I will add this, and here we need to provide our name for this IP configuration. This will be IP config. For example, let me add simple dash nic1. Then we need to add properties again, and here in the properties we will add private IP allocation method. It will be dynamic, and finally we need to add our subnet, and here we will add ID of our subnet, and here we will type subnet.id, and once again we need to add our public IP address. This will be public address, and here will be ID, public IP dot ID. And this is our script for now. And now that we have our code, I already added our subnet ID and public IP address ID. And now I want to show you some different options. Let me just add my mouse here, and I will now use again a resource. Then we will use our VNet. If you remember, if I go to our VNet, the name of our VNet is VNet1. Let me just go back to our VNet. This is just a symbolic name, of course. Then we will use Microsoft.network / virtual networks at the latest API version, and I will now use existing option equal, and here I will again add my square brackets, and in the name option, let me just add this to another line. I will add the name of our VNet1. Then once again, I will use a resource option. I will use my subnet. Here I will add my Microsoft Virtual Network subnets. Let me just type dot networks slash virtual network slash subnets at the latest. We need to add an S here and subnets. Let me just add once again. We will once again use existing option. Once again we will use our name, and here we will add a name for our subnet. If you go to our subnet, let me just see, we have subnet 1, the name of our subnet is subnet 1, and finally once again we will use our resource option. Here we will add our public IP address. Once again we will type Microsoft.networks slash public IP addresses at, we can simply copy this where are our subnets. Let me just add this for our where is our VNet subnets. Let me just fix this, this and I will continue. And finally I finish my bicep file. As you can see, I used existing option and parent option. What does this mean? This means that if you want to create your network interface card, of course, you must provide existing virtual network, existing subnet, and existing public IP address. If you want to attach this network interface card to this VNet, to this subnet, to this public IP address, and of course, when you use this existing option, you must add parent option to our VNet. What does this mean? That means that this subnet is a child of this VNet, or simply this VNet is a parent of this subnet, and that's it. And now I will simply save this file and we will run from here. As you can see, we will simply run open bicep file. If I click on open visualizer, you can see the visualization of this script. We have our virtual network, which is attached to our, we have our subnet, which is attached to our VNet, and this NIC is part of this subnet, and it is attached to public IP address, of course, will be attached to our network interface card. I will now run this script from here. Just want to show you that we have this option too. And finally, we will confirm our file. I will choose my resource group, none, once again, and deployment succeeded for our nic.1 bicep. If I go to our portal, let's go to our resource group, let's go to our RG1, we can see that we have our VNet1 public IP address, our network interface card, and if we go inside our network interface card, you can see that we have attached this public IP address pip 8907, and if you go one step back, you can see that this is our interface card. So that's it. Thank you for watching. In the previous lessons, we'll build almost everything that we need for our Azure virtual machine. But first, let's find out what is Azure virtual machine. An Azure virtual machine, or simply VM, is a cloud-based resource that gives you the flexibility of a server without needing to manage physical hardware. It's essentially an on-demand scalable computer in Azure that you can configure with your choice of operating system, size, and networking. Some key features of our virtual machine is that it is customizable. You can choose OS between Windows and different distribution of Linux. You can choose different CPUs, memory, and storage. It is scalable, so you can resize or add more VMs as workloads grow. We have networking. You can connect to VNets, assign public or private IPs, and control traffic with network security group. By the way, network security group is just a simple filter that can save your VM from internet, of course, with different rules. Then it is very secure, support encryptions, firewalls, and identity integration with Azure Active Directory or Entra ID, of course. All habits never change. It has flexible pricing, of course. You can use pay-as-you-go, you can use reserve instances or spot pricing for cost optimizations. Once again, if you want to learn more about these different services, you can go to AZ900 and see all these resources in great detail. Well, VM is a common resource in cloud world, and use cases for VMs are different. You can, for example, host your applications or website. You can run your development and test environments. You can extend on-premises data centers in the cloud. You can support high-performance or HPC, computing or batch jobs. It is an IaaS, infrastructure as a service offer, so you as a customer are responsible for almost everything. Now I will go to Azure portal and try to create a simple Linux VM. Well, once again we are in our Azure portal and I will simply go to our virtual machine. But before that I will create a new resource group just to simplify this creation. Let me create a resource group from portal and show you how can we do this. I will choose my RG2 name for this resource group. Of course I will choose my subscription, and this time I will use Central US as my region. Let's create our resource group. Our resource group is created. Let me just refresh this page. And here it is. We can go to our RG2, and here I can click on create and choose my virtual machine. Of course, we can choose different option, but if you type virtual machine, we can click on create virtual machine, go to this wizard. Once again, as you can see, it is automatically selected my subscription, my resource group. This will be, for example, VM1. I will choose my region as Central US. We don't need any infrastructure redundancy required. We will use images Ubuntu Server 2404 long term. And I will use the simple standard B1S with one CPU and 1 GB of memory. Of course, you can choose different sizes if you want. I will use my password. You can use public SSH key if you want. Let me just add my username and password. Finally, we will choose our SSH port, and for example, port 80. Let's go to disk, to networking. I will choose to create a new virtual network. This is our subnet. You can see there is a different subnet, 172.16.00. I will use my public IP address, and we will use our network security group, basic option. As I already mentioned, a network security group contains security rules that allows you to allow or deny inbound or outbound traffic from your virtual machine. So I didn't create NSG. That will be your homework, to create an NSG or network security group within your Bicep file. Now we learned a lot. We will go to advanced, and finally we will go to review and create to create this virtual machine. After this validation passed, I will hit on create, and here it is, just like that. We are submitting our deployment, and this VM will be created in a few minutes. Let's continue when this deployment finish. Well, once again we are in our Azure portal, and I will simply go to our virtual machine. But before that, I will create a new resource group just to simplify this creation. Let me create a resource group from portal and show you how can we do this. I will choose my RG2 name for this resource group. Of course, I will choose my subscription, and this time I will use Central US as my region. Let's create our resource group. Our resource group is created. Let me just refresh this page. And here it is. We can go to our RG2, and here I can click on create and choose my virtual machine. Of course, we can choose different option, but if you type virtual machine, we can click on create virtual machine, go to this wizard. Once again, as you can see, it is automatically selected my subscription, my resource group. This will be, for example, VM1. I will choose my region as Central US. We don't need any infrastructure redundancy required. We will use images Ubuntu Server 2404 long term. And I will use the simple standard B1S with one CPU and 1 GB of memory. Of course, you can choose different sizes if you want. I will use my password. You can use public SSH key if you want. Let me just add my username and password. Finally, we will choose our SSH port, and for example, port 80. Let's go to disk, to networking. I will choose to create a new virtual network. This is our subnet. You can see there is a different subnet, 172.16.00. I will use my public IP address, and we will use our network security group, basic option. As I already mentioned, a network security group contains security rules that allows you to allow or deny inbound or outbound traffic from your virtual machine. So I didn't create NSG. That will be your homework, to create an NSG or network security group within your Bicep file. Now we learned a lot. We will go to advanced, and finally we will go to review and create to create this virtual machine. After this validation passed, I will hit on create, and here it is, just like that. We are submitting our deployment, and this VM will be created in a few minutes. Let's continue when this deployment finish. After 2 minutes, our deployment is succeeded, as you can see. Let's go to our resource, and that's it. Just like that, we created our virtual machine. It's running. Resource group is RG2. We are in overview blade, as you can see. We are using central ES as a location. This is our subscription ID. This is our operating system. It is Linux. Size is standard B1S with 1 vCPU and 1 GB of memory. This is our primary NIC, public IP address. This is our virtual network and subnet, and time when this machine is created. And of course, this is our public IP address. Then, if I go to our RG2, when you create a virtual machine, there is the different resources. As already mentioned, we have our VM, public IP address, network security group, network interface, OS disk, and virtual network. I will now go to my VM and show you that you can connect using serial console, for example. So you don't need any additional software to connect to your VM. Simply you must provide your username and password, which you specify during the creation of your VM. Let me just add my password. Here it is. We are connected as Azure user to our VM1 via serial console. Now I can run, for example, sudo apt update to update our index package with as you can see. And finally, we can run, for example, sudo apt full upgrade to upgrade this machine, this server completely. But I want to show you one more thing. You can also install sudo apt install, for example, nginx. Just like that, we install our nginx server. Let me type clear to clear this. And if I copy our public IP address and paste it here, we will get our information. Then welcome to nginx, and now you can continue working with your VM. Now that we are finished with this VM, I will simply go to our resource group and delete the whole resource group that we created during this deployment. Simply copy the name of your resource group, paste it here. You can apply it to force deletion or simply click on delete, and this resource group will be deleted. Now let's go to our Visual Studio Code and see how can we create a virtual machine with the help of our bicep file. Now before we create our new file, just want to show you that I deleted all our content, all our resources from our RG1 that we created here. Now let's go to our Visual Studio Code. I will create a new file. This will be vm.bicep, and I will paste our code for our virtual machine. Let me explain what are we going to do. First, let me just expand this to see everything. I will add a parameter for our resource location as a string. This time it will be North Europe. For the resource, we are using our VNet1. As you can see, this is our simple, nothing with variables. We are using just one parameter to make this simple. Then this is the name of our VNet. This is our location parameter, and this is our address prefix. For the subnet, we are creating two subnets, subnet A and subnet B. Then we are creating our resource public IP address 1, same location. This will be, let me add standard public IP. Public allocation will be dynamic. We are creating our nick, and of course we are using resource ID. You can do just like this for our VNet1 and subnet A, and we need to provide public IP address ID and of course network security group ID. This is our storage account. We must provide a storage account when we create this machine. And in the previous chapter I already told you that you can create your network security group for your homework, and here it is. We created our network security group and I specified our location. In the properties, I will add a simple rule. This will allow RDP to allow remote desktop protocol, TCP, and that's it. It will allow, of course, inbound traffic for you. Then in the resource, we created our VM1. This is the name for our VM1. We are using exactly the same location. For parameters, this is our VM size, standard DS, D2S version 3. This is our compute name. This is our admin username and admin user password. Of course, you must protect your password, for example, from it. You can use different options, but for now we are using this simple username and password. Then we have publisher image reference, Microsoft Windows Server. This is based on Windows Server 2022 data center. Version is latest. OS disk is Windows VM 10. IS disk, read write from image. And finally, we are using our NIC ID. And in our diagnostic profiles, I added this storage URL from our resource ID. This is primary endpoint blob, and as you can see, this is our storage account, the name of our storage account, and that's it. I will now save this. Let me just go to file, click on save. This is our VM bicep, and we can go to our As you can see, we have our RG1. Let me go to our Cloud Shell. We will now copy our command for deployment. We will upload our script. This is a simple VM bicep. And I will paste my command, change the name of our bicep file. Change the name of our bicep file, and let's try to run this script. As you can see, we are getting a warning that we are not use admin username and admin password as a plain text, but for this exercise, for this simple bicep file, I will run this script. So let's wait and see, is this working? And after a few minutes, you can see that our provisioning state is succeeded. And let me just go to our resource group. This is our RG1 resource group. And here you can see that we have our NIC, our NSG, public IP address, storage account, VM1, VNet, and Windows OS disk. If I go to our VM1, I can try to download my RDP file. Let me check download RDP file. We can click on connect and let me add my password. If I remember correctly, our password is testing12345 of course. Let me hit on enter, and finally, if I hit on yes, you can see that we can log into our server. And that's it. This is how can you work and create virtual machines with the help of whole bicep script. I will now close this connection and let's move on to the next lecture. Well, in the last chapter we used our admin user name and password as a plain text, but that's the not convenient way to work. In Bicep, a secure string is a special parameter type used to handle sensitive values like passwords, secrets, or connection strings in a secure way. So, unlike a normal string, a secure string ensures that the value is not logged, not displayed in deployment outputs, but not exposed in plain text. As you can see, the key point of using secure string in our VM script, you can declare with parameters name and secure string. You can use this for sensitive data such as admin passwords or API keys. Values are provided at deployment time via CLI, portal, or pipeline. They are masked in logs and outputs to prevent accidental exposure. Of course, when we work in a production environment in a company or somewhere else, it is very important to know that sensitive things such as secrets, passwords, keys, and certificates must not be left as a plain text. That is why it is good practice to use the special resources in Azure called Key Vault, and its integration is possible and desirable in the Bicep file. But this time we will learn how to use our secure string in our VM script. But first, let's find what are the differences between strings and secure strings. Let me just grab my pen. Here, the purpose of simple string, that this is it generates text values like name tags, IDs. With secure strings, we can use for sensitive values like passwords, secrets, and API keys. When we use strings, it will be shown in logs, outputs, and deployment history. On the other side, secure strings are hidden, masked with logs and outputs. For the security standpoint, from the security, there is no special protection for strings. For the secured strings, exposure and protected are from accidental exposure, of course. Evaluations applied at the deployment time and our string are visible, and at the deployment type it is applied, but it's masked. Some example, as you already know, it is parameters, VM name, string equal my VM. On the other hand, in the secure string, we can use parameters, admin password, and secure string. Use cases, as I already told you, when we are using strings, we can use it for resource names, locations, and tags. When we are using secure string, we can use our admin credential, connection strings, and secret keys. Let's see how can you use our secure strings in our existing VM script, VM Bicep file. I will now create a new. Let me just copy all this complete script from our VM Bicep. I will create a new file. This will be, for example, VM secure string. Sorry, VMS secure, for example, .bicep, and I will paste the whole script here. First, I want to create a new parameter. Here, let me type param. Then I will add admin password, and I will add string. Here we need to provide @ and we will use secure, and that's it. One more thing we need to do is to go to our, just let me find admin password, and here I will simply change this with admin password string that we just created, and let me just replace this password with admin password, and that's it. I will now hit on save all, and here in our bicep I will try to provide this. Just let me check all the necessary option. We will now go to our resource group, but first let me delete the whole content of our virtual machine. I will type delete, and finally, after this deletion, we will be able to run this script and try to see if this really works. Our resources just deleted. Let me go to our Cloud Shell. I will now upload our file. This will be VMS Bicep. Of course, we will just add simple S and try to run this script with our secure string. As you can see, now it is asking us to provide secure value for admin password, and now I will add my password that we specified when we created this virtual machine. This will be testing 1 2 3 4 5 6, and then it will start with the deployment of our virtual machine. And that's it. This is the whole point of using secure string. You can see how easy to set it is up. And finally, we will see, we are now seeing that we are getting this information that we can use admin username, exactly the same, just like we used our secure string for admin password. We can specify another parameter for admin username, add our Azure username as a string, and then we need to provide that admin username and replace that Azure user. Simple as that, just like we did with our admin password. So the only difference is it will not be visible for anyone. So we are still waiting for our VM to be provisioned. And after a few minutes, as you can see, our provisioning state is succeeded. This is the date when we successfully provisioned our virtual machine. Let's go to our resource group. And finally, if I go to my resource group, you can see that we have everything in place just like before, but this time in our script, in our Bicep script, we are using secure string to protect our password. Now I will delete all resources from this resource group. I will leave our resource group as it is, and we will continue with our course. Thank you for watching for now. When you create Azure Virtual Machine, you have one disk, and that is an OS disk. And as you know, we can create separate disk. For example, this disk can be then attached to our existing virtual machine. I will not show you how can you create data disk or simple disk in Azure portal. It's so easy. You can go and try for yourself. I will show you how can you create this resource via Azure Bicep file. But first, let's create our Bicep file. This will be, for example, data disk dot bicep, and here we will create our resource. We need to add a symbolic name for this resource. This will be data disk 1, for example. I will be adding our Microsoft dot compute slash disk. Let me just find disks. Here it is, and we will add the latest version equal. First we will add a name. For this disk, name will be, for example, we can do data disk 1. Then in the next line we can specify our location. This will be, we're using, just let me see, in our Bicep file, North Europe. We can specify location as let me just copy from here this complete. And finally, in the after location, we will add SKU, stock keeping unit. We will provide the name. This name will be standard LRS. Then we will provide properties. As you can see, as you go typing, Visual Studio Code using that intelligence, sensitivity, sense, and you can simply go and add all these parameters or properties. In the properties, we will use creation data or creation option, as you can see. Here, I will use empty. And finally, here, we need to specify our disk size in gigabytes. And this will be 16, for example. And that's it. That's the whole process of your script. Let me click on Control S or use save, and we will run this from here. Deploy bicep file. I will choose my name for this. You can choose our Azure subscription. RG1 is our resource group, and we don't have any parameters file. We're waiting for our deployment, as you can see. And our deployment succeeded. Let's go to our resource group. Let me refresh this to confirm that we successfully created our data disk. And that's it. This is our data disk located in North Europe. As you can see, it is unattached. 16 gigabytes standard HDD LRS. And that's it. Well, now it's time to see how can we attach this data disk that we created in previous lesson. First, I want to create a new file. This will be our new VMD, for example, .bicep. D stands for data or disk. I will simply copy this script from the secure shell. Let me copy all of this to our VMD bicep. And if you go to our, it's exactly the same script, just like in previous, when we learn about secure shell. And here, let me just go to my disk. I want to add our data disk. If you can see in our OS disk, we need to add data disk. And here I want to provide my name. The name of this data disk will be data disk 1. Then we need to add our disk size. This will be 16 gigabytes. We're just adding a number or integer and create option. I'm typing this just to show you that it's very easy to add this. And finally, we need to specify a logical unit number, and it will be 0. And that's it. That's the whole point of the whole job, just to sorry, this is for our data disk. We are going to add this here, and I hope that this clears our script for deployment. Let me just save this long script And I will now go to our resource group. This is our data disk. Let me once again run this Cloud Shell with our AZ deployment group create. It's easier for me to prepare all this. There is so many scripts here, so it's easier for me to work. We will first upload our VMD file, and let me just paste this command, and sorry, we will be adding, let's add our name VMD, and let's hit on run. Let me add my password for this VM. And now it's start with provisioning of this virtual machine. Well, as you can see, our file contains some errors. Let me simply go and remove or fix this. First, we need to use disk size GB. This is the complete line, and create option is empty. Now we will save this, and finally let's deploy our bicep file. You can do it from here. Let's try from here once again. I will now once again upload our file. This is VMD, and let's type AZ deployment group. We need to provide our admin password. And finally, let's see if we can create this virtual machine with our data disk attached to this machine. It is always good to see and check all your failed messages, because that's the way how we learn. Nobody knows everything, but that's it. Of course, fails and errors are part of your job, part of your learning. Our deployment is succeeded. As you can see, our virtual machine with our data disk. If you're getting an error, just like me, you need to delete all your deployments in your resource group. That's the whole thing, and simply run this script once again. If we go to my resource group, let me refresh this. You can see we are having our data disk, VM, and everything else. If we go to our VM, if you go to our disk, you can see that we have one OS disk and one data disk that is attached to our virtual machine. And that's it. We are now finished with these resources. I will delete once again the all resources that we're using while practicing and learning about Bicep. Let's go to our next lesson. An Azure Web App is a service within Azure App Service that lets you build, host, and scale web applications without worrying about managing infrastructure. It's a platform as a service or PaaS offering, meaning Azure takes care of servers, operating system patching, load balancing, and scaling for you. Some of the key features of our Azure App Service is that this is a fully managed hosting, so Azure handles OS updates, scaling, and infrastructure. It has multi-language support. You can build apps in .NET, Java, Node.js, Python, PHP, Ruby, and more. You can deploy directly from GitHub, Azure DevOps, or Visual Studio with one click. Publishing, you can scale up to bigger instance or out more instances with ease. You can connect to databases, APIs, and services via Marketplace. Of course, security compliance, it has built-in authentication, SSL certificates, and enterprise-grade compliance. Some use of common use cases is you can host your website and APIs, you can run business apps without managing servers, you can quickly deploy prototypes, production apps, integrate with CI/CD pipelines for automated deployments. In short, Azure Web App is the easiest way to get your web application online in Azure. You focus on your code while Azure handles the infrastructure. Well, now it's time to see how can we create our web app. If I go to our app services, you have an option to create web app with database, or WordPress on app service, of course. I will hit to create a simple web app. We already know what is a web app. I will choose my subscription, choose my existing resource group. Let me add a unique name for our web app. And I will use my code. We will select our runtime, for example, .NET 10. I will host this in, for example, Central US. If you're getting an error while creating Azure Web App, this is because if you use East US, for example, maybe you are done, maybe you have exhausted your quota for that service. So we are using Central US for our region. I will use our Windows plan, for example. This is the name of our Windows plan. We are using pricing plan basic. And here, I will now stop this to explain what is an app service plan. Because when you're creating an app service, our service plan cannot work without app service plan. This is just a compute resource pool that powers your web apps, APIs, apps, and functions. App service plan is the compute resource, of course, and you can think of it as the server behind your app. You don't manage the VM directly, but the plan defines the CPU, memory, and scaling features available to your applications. Well, the key concept of app service plan is that you can specify your region, instance size, and pricing tier for your apps. All apps in the same plan share those resources. Also, behind the scenes, it's essentially a virtual machine managed by Microsoft. You don't patch or maintain it, you just deploy your code. Also, you can scale up to a larger instance with more CPU and RAM, or out to add multiple instances. It's really dependent on your demand. Well, there is some pricing tiers. As you can see, we have free, shared, basic, standard, premium, and isolated tiers, in which have different performance, scaling, and feature sets. Also, you can use this app service plan for multiple hosting. You can host multiple web apps in the same plan, but all these web apps share the compute resources. So let's make it simple and choose our B1. Let's go to next. I won't use database. For our deployment, we are not using continuous deployment. I will leave everything as it is, and I will not use application insight. Let's click on no. This is also a separate resource for your application performance management, so you can track all information about your web app. Let's hit on create. Now the validation is passed, and we are waiting for our deployment. And very soon we will have our web app deployed, and after that we will go to our Visual Studio Code and try to create Azure Web App with the help of our Bicep. As you can see, our web app is complete. I will go to my resource, and That's it. This is our web app. If I click on this default domain, you can see that our web app is ready to host our app, of course. It takes time to provision this link, but you can click here and check all this by yourself. I will now go to our resource group, and as you can see, we have our app service, and so on, app service file and so on. Let me just go to our Visual Studio Code and define our new file. This will be simple called web app.bicep. Here we need to type our resource, and our symbolic name will be unique name for our app service plan, because we must first create our app service plan if you want to create app service, of course. Let me just add a simple name, and this will be our name. Then we need to add our Microsoft dot web / server farm. We will add our latest API equal, of course, curly brackets. We need to add a name first for our plan. Sorry. Let's add a name. Name will be exactly the same as our plan. Of course, you can use variables for or parameters for name and location, but I won't use this right now. Now let me simple do it right here. Plan will be located in, let me add Central US once again. Let's see if this works. Then we need to add our SKU. First, we need to add our name. This will be F1. Then we need to add our capacity. Capacity is simple integer, it will be 1. And after that, I will provide our properties. In the properties, we will leave as empty. After that, we will add a new resource. This resource will be our app service. Of course, we need to provide our symbolic name. This is just a demo, so I will be adding some demo name, some random name. Here we need to add Microsoft dot web / sites equal. Once again, we need to add our name. Let me just copy this demo once again. The name must be unique, if you remember. Finally, we will add our location. Location is Central US. Then we must add properties. For the properties, we need to add our server farm ID. This is our plan.id, if you remember. And finally, we need to add our site config, and we need to add what language or framework we want to use. Framework version, this will be version, for example, 6.0, and that's it. That's the whole script. So when you add your server farm ID, you are adding your resource ID for your app service plan. Let me save this. If you press Ctrl S or simply go here, you can click on save. Now I will go to my resource, to my portal, and let me upload my bicep file. This is our web app bicep. So we need to run again, because our Cloud Shell is open. We need to once again copy our deployment group create. Let me upload our file. This is our web app. Let me copy our command, and we need to once again add our web app.bicep, and we will run this and see if it's working. 1 or 2 minutes, we're getting clarification that our provision was succeeded, and as you can see, we successfully added another plan, as you can see, and our web app is ready to host our code. Let's go and see how can we create our SQL database, for example. Azure SQL Database is a Microsoft fully managed cloud-based relational database service built on SQL Server technology. It's a part of the Azure SQL family and is designed to provide scalable, secure, and intelligent data storage without the overhead of maintaining or managing infrastructure. Some of the key features of SQL Database is that this is a platform as a service offer or service. So it means that Microsoft handles patching, backups, upgrade, and monitoring automatically. You can use something called elastic scaling. It supports scalability, including hyperscale tier for very large workloads. High availability is has built-in redundancy and failover ensure uptime and business continuity. For the security standpoint, it has advanced threat protection encryption and compliance certification. You can use machine learning to optimize performance and adapt to workload patterns. It uses a multimodal support, so it stores structures, semi-structures, and non-relational data. Common use cases of Azure SQL Database is that you can host transactional applications or OLTP. It's running SaaS applications that need reliable, scalable databases, migrating on-premises SQL Server workloads to the cloud, and supporting analytics and reporting with integrated tools. Let's go to our Azure portal and see how can we create this from portal. Let's create our SQL database. If we go click on this link or SQL database, you can see that we can create a different types of databases. I will create a simple database, so let's hit on create and choose SQL database. Here we need to provide some different options like our subscription, our resource group, but if you want to check out this offering, there is an offer, of course, that you can apply and choose to work and create a serverless Azure SQL database. But for now, let me just choose my resource group. Let me add this DB name. This will be, let me ADB SQL, for example, 1000. We don't have server, so this database needs to run somewhere, and behind the hood all these databases run on virtual machines, of course, and we need to create that server. I will add a server name. This will be db server 1000, for example. Location will be East US, so we don't have, as you can see, access to create server in the selected region. I will choose a different region. We can use, for example, North Europe. Then you can choose your authentication method. You can choose between Microsoft Entra only authentication. You can use both SQL and Microsoft Entra authentication, or simply use SQL authentication. I'll use simple SQL authentication. For that, we need to add our login, username and password. Let me confirm my password, OK, and let's click on OK. So we set up our server, and that's it. We are, as you can see, using our server in North Europe. We do not want to use Elastic Pool. We are using this environment for development, and then we can choose our compute and storage. You have two types of service tiers. We have, as you can see, DTU based purchasing mode, two purchasing modes, sorry. DTU, data transaction unit. You can choose between basic, standard and premium offering, and we have vCore based on purchasing models. We have general purpose, hyperscale and business critical. Then I will choose the simplest database. This is basic DTU for less down demanding workloads. Everything is fine. This is the estimated cost for this month. I will hit on apply. If you want to backup your databases, we will use local redundant storage, because this is right now the most simplest way to create this resource. Of course, you can choose your connectivity method. In the production environment, of course, this database will not have any public access, but for this demonstration, we will choose public endpoint, and in the firewall rules, I will click on yes to allow services and resources to allow this server, and yes, I want to add my IP address to this database, and that's it. Let's go to security, additional settings. We will use our sample database. Let's hit on OK. This will be adventure workload. Let's go on tags, review and create, and finally, after validation, let's hit on create to create this database. So we are creating database, and of course server, and we are now deploying this. This deployment is in progress, and I will get back to you when this deployment finish. After some time, our database, SQL database, is created. As you can see, if I go inside our resource, we have our database and we have our server. If I go back to our database, you can see that we have something called query editor, and here you can add your password. Sorry. And if I hit on OK, we can log into our database, and here you can see that we have some tables that we provided during the creation. This was Adventure LT table, and just like that, you can run, select one top 1000 row, and you can check your database. So this is our database. Now let's hop to our Visual Studio Code and see how can we create SQL database from with the help of our Bicep file. let's create our file. This will be, for example, SQLDB.bicep, and I will paste the whole code. As you can see, I already prepared this script because I want to save on some time. We really looked at different resources, how can we create. We really learned a lot, and this is the last lab about individual resources. So let's stick with our DB. First, as you can see, I created some parameters for our location. This is our resource group location. Parameters for our SQL name, SQL server name. This is our SQL server name. Parameters for SQL admin username. This is our SQL user. And then for the SQL admin password, I added a secure string. We already know that. For the parameters, I added SQL database name. This is our database name. And this is our client IP address. I need to add my IP address here. Let me just once again go to our DB and set firewall server. Here, this is my IP address. As you can see, I will simply copy this address. You can find your address if you type what's my IP and so on. Then I will simply copy my IP address here, click on save. And finally, the first resource is our SQL server. As you already know, I added the name. This is a parameter, as you can see, for our name, location, SQL administrator login, SQL admin pass, version is 12.0. Then the next resource is our SQL database, of course. We are using the name for our SQL name and SQL database. For our location, as you can see, all these are parameters. String, of course, this is a collation. Maximum size, name is basic capacity is 5. It depends on, this is the clause, as you can see, depends on, because our SQL database is hosting on that server, on that virtual machine. So it depends, that resource depends on the previous one, if you remember. And then I want to add our firewall role, as you can see, and this is our name for our SQL name, allow client IP, and the client IP is our or my IP address, and it depends on SQL Server once again. Finally, let's hit on save, and this is our SQL DB. Let's go to our Cloud Shell. We are using a new Cloud Shell, so let me copy once again our deployment. Of course, all of this we can deploy it right from Visual Studio Code, but I want to show you the most convenient way how to work with different options. Let me first add this is our SQL DB. Here it is, bicep, and I will paste our command. Let me change my name for our bicep. This is our SQL DB, and let's hit on enter. Of course, we need to provide our SQL admin password. Let's hit on enter again, and very soon I hope we will have our resource deployed. If you are getting this error, this is because your resource group is located in East US, and we are using our resource group location for all of these resources. The first thing we need to do is to delete our resource group 1, and we will create a new resource group, of course. Let me just go to our resource group, and this will be RG2, for example, located in some different, for example, UK, or let me choose some different, for example, West US2. Let's hit on create to create this resource group. And after that, because recently Azure is, for I don't know why, you need to write support ticket to request quota for some regions, for some deployments of some resources. So we are getting this error very soon, let's wait until our resource group is deleted, and then as you can see we have now RG2. Now let's try to once again upload our SQL DB, and let's try our luck this time in a different region. This is our West US2. Of course we need to provide our SQL admin password. And finally RG1 could not be found, but we are now using RG2, and this is a mistake. We need to change our, and finally let's see if we can deploy our template. So believe me, I can record this without any errors, but that's not the point. The point is that you know how to troubleshoot and what is the problem for your unsuccessful deployments. So let's see if we can finally deploy our SQL database. So finally we have succeeded. As you can see, we are getting a response in JSON file. Let me close this Cloud Shell. Let's go to our RG2. As you can see, we have our SQL server, SQL database, SQL server located in West US2. The main problem for this deployment is our regions. So recently Microsoft or Azure updates are limiting a lot of stuff with these regions, with quotas. So I can understand why it is limiting in East US, because East US is one of the most used regions. So just simple change the location of your resource group, because we are using that parameter for resource group location. As you can see, that was the main problem in our script. So let's go to our SQL server. As you can see, we have our SQL server, and if you go back to our RG2, we have our database. And here, if I go to set server firewall, you can see that we already added our allow client IP. So with the help of this, I can log in to my database, of course, and we don't have any tables. As you can see, I can use my SQL admin user and add my password. And I'm logged in. As you can see, I don't have any tables, so we can create a new query and write from here. So with this demonstration, I'm done with presentation and writing a bicep file for single resources. Okay, we added some multiple resources, but it's time to delete our resource group 2. I will now delete everything, and we will delete, of course, our network watcher. And finally, we will try to learn more about some complex or real life projects. But before that, we will learn more about biceps and some things that we already saw in our labs. In this chapter, I will try to summarize most of the terms that we are using in bicep. And most of these terms we already used in our previous demonstrations. So let's start with outputs. Outputs is used to return values from bicep deployment. It is helpful when you want to pass information like resource IDs, connection strings to other templates or scripts. As you can see, this is the simplest example of how can you use output. You can use storage ID string and it is equal to storage ID. So this is output. Then we have something called depends on. We already looked and how can we use in the previous lesson. It is explicitly declares that one resource must be deployed after another. Usually bicep infers dependencies automatically, but you can use depends on when the relationship isn't obvious. As you can see, this is how, for example, can we add that this NIC depends on our VM. Then existing option is used when you want to reference a resource that already exists in Azure instead of creating a new one. As you can see, this is our existing option. We use this when we create our virtual network, and then when you want, for example, that subnet to use that VNet, you can use this existing option. Then we have something called parent. It defines a hierarchical relationship between resources. It is useful when a resource is a child of another, like subnet inside a VNet. We already know how we can use this. This is just a simple explanation. How can you use subnet from your VNet? In this case, VNet is a parent and subnet is a child of that VNet. Then we have something called target scope. It specifies the deployment scope of the template, like resource group, subscription, management group, or tenant. Then we have our function, and let me just show you target scope. We already use this, as you already know, and we have something called functions. This is just a built-in helpers that you can use like expressions like string manipulation, math, or resource lookups. You can see that we can use concat for VM unique string, resource group ID. It builds a unique name, for example. You can use resource group dot location. It gets the current resource group location. Then we have length, like array var. It returns the number of items in the array. So there is a lot of functions that you can use. In short, outputs returns values, depends on control deployment order, existing reference existing resources, parent define hierarchy, target scope set deployment level, and functions is just a built-in helpers for logic. Next, we will learn more complex things. It's time to know what are modules in bicep. At the end of this part of this course, in which I showed you a lot, that is how can we create a bicep file and how we can create or we can create individual resources along with the presentation of the basic definitions that we used and will use in the further work. My advice is to continue creating individual resources and continue to writing files. Of course, working with individual files or writing and creating resources is only one way to practice. While more serious work in a company environment requires more specific knowledge. Now it's time to introduce you to a new term, which are modules. Until the end of this course, we will work exclusively with modules, and before we get to know this option, let's see what it is theoretically. So in Bicep, modules are a way to break down and organize your infrastructure code into reusable, maintainable pieces. Instead of writing one huge Bicep file, you can split it into smaller files and call them as modules. Well, a key points of modules that a module is simply another Bicep file that you reference and deploy from your main template. It helps with reusability, readability, and maintainability of complex deployment. You can hide implementation details inside a module and expose only parameters and outputs. The same module can be used across multiple projects and environments. Well, a module can be another Bicep file, .bicep, or an ARM template, .json. Benefits of using this way or using module: you have a clearer code. It's easier to read and maintain. Modules can be shared across other teams. For example, you have development team, you have production team, you have test team, for example. And then the same module can be used and shared across teams. It is consistent, enforce standards by reusing the same module. You can manage large deployments by breaking them into logical units. Well, main template orchestrates everything, calling modules like Lego blocks. As you can see in our diagram, this is the whole infrastructure. So, modules are a smaller, as I already told you, .bicep files, which are defined specific resources. So you can put there in that files, you can, for example, use one module for networking, one modules for storage, and the other one for compute. Then parameters are passed into modules and outputs are returned back to the template. As you can see, these structures keep deployment clean, reusable, and scalable. In short, modules let you split your infrastructure into logical units, networking, storage, compute, and then stitch them together in the main template. You can use resources when you just need to declare something directly, or you can use modules when you want structure to be reused and encapsulation, especially if you have some large deployment. In our, as you can see, let me just grab my pen to make it clearer. This is our main template. This is our main Bicep file. So in this Bicep file, we can create parameters, for example, for location and for app name, as you can see. Then we creating a module, for example, for network module, storage module, and compute module. These modules, network, storage, and VM biceps, are separate files. In those files, we need to add our files, our parameters, resource files, and resource. What is resource? And then in the main template, we must provide our path to this bicep. For example, module network will be ./network bicep, as you can see, So here we are calling our module in the main template. And that's the whole point of using modules. As you can see, we have differences between modules and resources. If you use resources, this is just a single Azure resource declared directly in our Bicep file. We are using modules or template, reference and deploy it from another file, for example. When you use resources, you can define one resource, for example, VM, VNet, storage, etc. In your modules, you can create, and this file can contain multiple resources, parameters, and outputs. You can provision individual Azure services with resources. On the other hand, with modules, you can organize, reuse, and encapsulate groups of resources, as we already learned. But if you work with resources, they are limited. Resources definition and tied to one template. Here in modules, you can use your modules, can be used across projects and different environments. As I already told you, for example, you can have test, development, and so on. When we talk about complexity, resources are just simple direct declaration. Modules, you can add structure and hierarchy for large deployments. Parameters accept values directly in the resource block, and modules accept parameters passed in from the parent template. So again, parent and child we have in here. As you can see, outputs for resources is not just a typical for single resources. In the modules, you can return, for example, outputs like IDs, connection strings, etc. to the parent template. Some kind of example, as you can see, this is our resource VM, and there you go. We already saw how can we create a template. But when you use your module, you need to add the name of that file that you already create and add a path from that child file to our main template. And that's it. That's the whole point of module. You can see that we can use resources when we just need to declare something directly, and you can use modules when you want structure, reuse, and encapsulation, especially in larger deployments. One of the questions is why it is important to use modules in Bicep. Well, using modules in Bicep is important because they bring structure, reusability, and scalability to your infrastructure code. Instead of writing one large monolithic template, modules lets you break things down into logical building blocks. Here, why are they matters? Because with modules, we have some kind of organization and clarity. Large deployments can get messy. Modules let you split networking, compute, and storage into separate files, making the code easier to read and maintain. Then it matters because of reusability. A well-written module, for example for a VNet or VM, can be reused across multiple projects or environments without rewriting the same resource definitions. So you write one script and then you can pass to all your teams and different environments. When we talk about encapsulation, modules hide implementation details, so you expose only parameters and outputs, so consumers of the module do not need to know internal resource definition. Then consistency, teams can standardize modules, for example, a secure VM model, and ensure that deployments follow the best practices every time. When we talk about scalability and infrastructure growth, modules helps you manage complexity by breaking data deployments into smaller manageable units. And finally, when we talk about collaboration, I already told you that different team members can work on different modules, for example, networking, storage, compute independently, and then stitch them together into the main template. So you can, for example, have one employer working on networking module, the second one working on the storage module, the third one will work on compute module, and then when you stitch all that modules together, simply you can use them in the main template and build your infrastructure very, very fast and very easy. In the next chapter or lesson, I will show you how can we deploy our first resource with modules. So let's move on. Now it's time to see how can we deploy our first bicep file. This time I will write this bicep file, and it takes time to be written. But first, as you all know, we are using our bicep1 folder. I will simply go to my C drive. Let me just find my C drive, and here on my hard drive I will create a new folder. This will be project 0, for example, and inside that file I can create complete infrastructure. For example, I can create a new text document. This will be my main.bicep file, and then I will create a new folder. I will call this folder modules, and inside that folder I will create a new txt file, and this will be our storage.bicep. Here it is. Now this is one way how can you create your hierarchy in your modules. Of course, this is for all of those who are struggling to work with in VSC. Now, if you go to our Visual Studio Code, if I go to File, Open Folder, and select my P0 folder, I already have my infrastructure with one module and one storage file. The only thing you need to do is to delete this .txt, and here it is, your files are ready to work. This is one way to create your infrastructure. As you can see, you can create right from here. You can create on new folder, add a name for your module, and inside that module you can create a new file and simply create a new main.bicep file. So now that we learn the easiest way how can you use your infrastructure, your schema, I will now go to my storage bicep, and first we will type everything that we need to create our storage account, because this is the main thing of this exercise. I will go to storage bicep, and then I will start with typing. The first thing we need to do is to add our parameters. Let me first type param, for example. We need a storage name. Our storage name will be string. The second one parameter will be our location. It will also be a string. The third parameter will be our SKU name. This also will be our string, and I will hit on equal, and we need to add, for example, standard LRS. Here for our location I will use my resource group dot location. We already know how to create this. Then I will add another parameter, this time for what kind of storage account we want to create. This will be once again string equal, and then I'll add our storage version 2, because we are creating our general purpose version 2 storage. The next parameter will be access tier. So it is also a string. This will be hot. And finally, we have our 5 parameters in our storage.bicep. I want to add a description for all these parameters, so we can simply add description, and here I can for example add the name of the storage account to create, for example, and the name must be globally unique. That's our first description. The second description for our resource group will be again description, and here I will type the Azure region where the storage account will be created. It also defaults to the resource group location. So we are using our description. As you already know, this is a full project, so I will show you how can you work, for example, in some company environment. Then we need to add the description for our SKU. This will be the SKU for the storage account. And for example, I can add example like standard LRS standard GRS and so on. And then I will add a description for the kind of our storage. For example, sorry, I made a mistake here. This SKU will go here. I will just copy and replace with here, and let me just go this to undo, and we will type our description for our storage version 2, for example, the kind of the storage account, here we can add some example. We can add, for example, storage v2, then blob storage, or for example file storage. It really depends what we want to achieve. Then the last description I will add to our access tier, and here it will be the access tier for the storage account. For example, it can be hot or cool. Let me add this description. It can be hot or cool, for example. And that's it. We edit our parameters and edit description in our storage bicep file. Now I want to add a resource for our storage account. Let me just add a resource. Then we need to add a symbolic name. Let me add, for example, storage account, and we need to add our provider, Microsoft.storage / storage account. Let's choose our API equal square brackets. Here we need to provide our name, if you remember. The name for our storage account will be storage name. This is our parameter, if you remember. Then we need to add location. Location is simply location for our parameters. Finally, I will add my SKU. The name for our SKU will be our SKU name, if you remember, from our parameters. Here we need to add, just let me move this into next line. Here we will add our what kind of storage account we want to achieve. This will be kind. Finally, after that I will type properties, and in the properties we need to add our access tier, and our access tier is access tier parameter, if you remember. I will add a description for our resource, and here I can add, for example, the storage account resource, and that's it. That's the whole file for our storage.bicep. Now we will move to our main bicep. Here I will add another string, another files, and here let's go to our main.bicep. I will simply copy our descriptions and parameters from here, and we will go to our main bicep. Let me paste this, and now first I will change our storage name. I will add the name for my storage account. This will be, for example, some simple name, my storage. The name must be unique, if you remember. My storage account 1, 2, 3, 4, 5, for example. Of course, we need to use our string, and here I will change my description, the name of the storage account, to deploy. Let me change my parameters for our resource group location. The other region where the storage account will be. Let me change this to deploy. We are now simply changing everything that we need. Finally, parameters for our SKU name is standard LRS. Here I will add the SKU for the storage account. Then parameters for our kind, it is storage version 2. The kind of the storage account, we can delete this. And finally, our description for our access tier is the access tier for the storage account, we can delete this, and the access tier is hot, and that's it. Now in the next line I will add module, as you can see. And now what we need to do, we need to add, for example, storage module, as you can see, and here I want to add the path from my file from here. As you can see, the path is modules storage.bicep, and that's it. I will simply use my dot slash, we can use modules and storage bicep, and that's it. That's the whole connection within our storage bicep. Then I will hit on equal. We will use our square brackets. Now we need to add the name for our module. Let me move this to the next line and choose our name. The name, for example, will be storage deployment. Then in the next line I will use parameters. Here we will open a new square bracket. We need to add our storage name. Our storage name is, for example, my storage name. If you remember, this is our parameter. Let me simply change this parameter to my storage name. Let me just check out bicep. And here it is. The next line we need to add is our location. Let me add our location. Our location is, once again, location. The next thing we need to do is SKU name. We will add our SKU name. Let's go even further. We need to add our, what kind do we want here. Kind is kind. Finally, we will add our access tier, and let's add our parameters for access tier. Then I will add my description here. This is how deploy the storage account module. Finally, the last thing we need to do, in the new line, we will write our output. I will use output. Here we will add deployed storage ID, then string. It is equal to storage module dot outputs dot storage ID. In the description, I will simply write the resource ID of the deployed storage account from the module. And that's our whole script. Well, the whole script is now in place, and I want to create our simple storage account with the use of our modules. It really takes time to type everything, but this is just a practice. I want to show you how can you deploy a simple resource using modules. In the next lessons, I will simply avoid this part of typing because I want to show you something else. Here we need to save our file. Let's click on Save All. And now I want to, for example, use my terminal. And here I want to run simple command az account login, and then I will use -- tenant, and here I need to add my tenant. I need to go to my portal, to Microsoft Entra. Let me copy my tenant ID. I will now go back here, paste it, hit on enter to log into my account. Sorry, we don't need account, we just need AZ login. Let's try again. I will choose my account, click on continue. I need to choose my subscription because I have 2 subscriptions, and finally we are able to log in. Let me type AZ account show. As you can see, this is my account, and now I can work directly from Visual Studio Code. The first thing I want to do is to create my resource group. Our resource group, the command is AZ, if you remember, group create, then -- name. Our resource group will be simple RG1. For example, you can add whatever you want, and here I will use -- location. Let me add, for example, East US. Then we need to type enter to create this resource group, and it is succeeded, as you can see. And now I want to deploy my bicep file, but first I want to show you something else. When I go and try to type AZ deployment command, AZ deployment group, there is another great thing about bicep. If you want to use what if command, then I need to add my resource group. This is our RG1, and then -- template - file. This is our main.bicep file, if you remember, and then we need to add our parameters. And here we need to add, for example, we need to add parameters, -- parameters, and I will add my the name of my storage account, of course. And the name of my storage account is this. As you can see, this is our parameters. Then the name of my storage account is my storage name equal, and then we need to add my storage and the name of our account. I will simply copy this from here and paste it here, and let's hit on enter. Now with what if command, you can see what will happen when you create your bicep file, but it will only go as your report. As you can see, here it is. As you can see, resource change, there is one resource that you want to create. Here it is. If I scroll, we are using our what if command. As you can see, we are getting our response back in JSON file. It is not provisioning. We are just using what if command. As you can see, the result may contain false positive prediction noise. You can help us improve the accuracy and so on. So if you want to create this resource, you can type az deployment group create. With what if command, you are only getting a report what it will be deployed. So if you're creating a large set of resources in your environment, use what if command. Now I will change this az deployment group. We will delete what if command. We will use create because I want to create this storage account. Let me hit on enter. We're using exactly the same command, exactly the same template file, and exactly the same parameters. So what if is a very good feature if you want to first audit your whole script. As you can see, it is running, and after some time our storage account will be created, and we are working from our Visual Studio Code. As you can see, if you try to work from Cloud Shell, for example, there can be some mistakes, so avoid working with modules from your Cloud Shell. Work directly through your Visual Studio Code. As you can see, our provision state is succeeded. Let me go to my portal. We are going to our resource group. This is our RG1 group, and finally we have our storage account that we created using bicep file. As you can see, it is standard, locally redundant storage version 2, it's general purpose, succeeded, and the time that this account is created. Now I will delete this account because we are using only this account for exercise. We successfully deleted our storage account. Let me refresh my resource group, and after some time our resource group will be empty, as you can see. Let's go to another lecture. I want to show you another example of how can we deploy our storage account. Now that we know how can we use modules with a simple storage account, there is another option if you want to create some resources. Well, we will use exactly the same module, storage bicep, main bicep file. But first, let me go to my file explorer. Let me go to my C drive. I will prepare another folder. This will be p.json, for example. And the only thing I want to do is to go to my project 0, copy my module and main file. Let me find my p.json here, and here I will simply paste this. Now, because I'm repeating this in a new file, I want to have more projects. Let me click on File, Open Folder. I will use my pjson. Let me select my folder. We have our models and we have our bicep. I will now create a new file, and this file will be called. Now in this JSON file, we have our schema, content version, and in our parameters, you can add different values. For example, my storage name, we have the name of our value of our storage account. In the location, as you can see, we have value of East-US. We have our SKU name. This is standard LRS. What kind of value of our storage is storage version 2, general purpose, and access tier is hot, for example. So every value that you have in your, for example, storage account or main bicep, you can use in this parameters.json, sorry. Now let me just check the name of my account for our bicep file and, sorry, for our parameters file. Let me just save this, and this is the real name of our. Let me just copy this once again and paste it here. And now we'll save this again. I will copy the value of my storage account, and in the main bicep we need to change the name of our storage account because you can get a lot of mistakes by using this name, because we already used this name in the previous chapter, so I added just one number to expand this name of my storage account. And then everything remained the same. We have our main bicep file exactly the same, just like in previous section. We have our storage account exactly the same, but the only thing is our parameters file, which we are storing our value. If you want to, for example, create another module, file, for example, for VNet, then simply in this parameter file, you will add another value for that VNet, and it will work. Let me just go and save this and save all. Here it is. I will once again run my terminal. We are once again connected to our resource group, but this time I will not use my what if command. I will use az deploy group create. Exactly the same resource group, exactly the same template file, but this time I will use my parameters. In my parameters, I need to specify different type of parameters. Let me add parameters dot JSON and hit on enter. So we are trying to create a different storage account with different name, but this time we are using a different type of deployment. We are using our parameters JSON, where we stored all our values, as you can see, and we are using exactly the same command, Azure CLI command from our Visual Studio Code, but this time for the parameters we are adding our parameters file, and very soon we will be able to see that we can create our exactly the same storage account with this time with a different name, but with a different type of deployment. As you can see, the provisioning state is succeeded. I will now go to my storage account. This is our resource group, and let me just refresh this page, and here it is, our storage account, exactly the same with the same value, just like the first one. This is standard locally redundant LRS, storage version 2, general purpose version 2, location is East-US. I will now once again delete this storage account because we don't need our storage account anymore. And let me copy the name of this storage account. I will paste it here and click on delete. But before we finish with this lecture, I want to show that if you're seeing this problem, it is unable to load schema. This is an old version. There is also another version to create our modules and work with modules. But first, let's go step by step. Thank you for watching this, and you can try different types of deployment, and of course you can try what if deployment. Now that we know how can we deploy our storage account using our parameters, let's see another example how can we create some different resources. I will now go to my file. I already prepared a file to save on some time, and I will open my P1 folder. As you can see, I already created all my modules, and we just need to remove this txt file, and this is our parameter file, our JSON. We will be using our JSON file. Let me just add this is parameter.json, of course, and in our modules we have NSG module. This is our first module. We have Bicep module for VM, and we have VNet module. This is our infrastructure. As you can see, files are already in place, and now I will explain what I want to do. If I go to modules for our NSG module, we can, for example, even use a different name. We will use our nsg.bicep. It's a better and clearer name. Let me just prepare this, and finally let me rename this. For example, this will be our VM Bicep, and that's it. Now it's more clearer. Here in our VM, we are describing our VM name, our location, our subnet ID, our NSG ID, our admin using string, and admin password. As you can see, I will use this as a plain text because this is just a simple example. Then before that, this is all parameters, of course. Then we build a block in our VM for our network interface card. As you can see, we're using vmnick for our name location. This is our IP configuration. This is our subnet ID. This is our network security group. And we are using our as a resource our VM. We are creating this from these parameters. We are getting these strings. As you can see, this will be standard B1S machine based on canonical. This will be, we are using 18.04 LTS, or we can simply change this to 24 if we want, the latest version. This creation is from image, and as you can see, network interfaces we are getting from our NIC ID. This is our resource ID, and the output is VM ID, is a string from VM ID, and that's it. In our NSG Bicep, we are specifying the name of our NSG, the location for the NSG, because this is a separate resource, of course, and finally we are adding our NSG name, our location. what kind of priority we want. This is allow SSH, and we want simply to be able to log into our virtual machine. Of course, the next thing we need to provision is our VNet. We need to add our name for our VNet, location for the VNet, subnet name, the address prefix 10.0.0/16, and subnet prefix, or address prefix and subnet prefix 10.0.0.0/24. Of course, for our resource, we are using our VNet. We need to specify our VNet location, address prefix, and subnet name, and we are getting an output subnet string from our VNet properties subnet because we have only one subnet. And that's it. That's the whole point of this. We already know how to create parameters, strings, separate resource, individual resource. Now all that practice from our first part of this course, when we create our separate resources, this now has taken a full effect, of course. And then all these modules that are here, we need to specify in our main bicep, as you can see. Here we are using our location for all resources. This is our resource group location. This is our East-US. This is our VNet name, our subnet name. This is our parameters NSG name and description for our VM1 and VM2. We are using admin password and admin username. We can now deploy our VNet. As you can see, this is our bicep file. We are now calling our module, VNet module from here. This is our address, as you can see, modules.vnet.bicep. Then we have our NSG, modules/nsg.bicep, and finally we have our VM1, modules/vm.bicep. Now the paths are good. This is our both VM. Of course, we can specify iteration for both of this VM, but I want to use this. And for the output, as you can see, we're using simple VM1 ID string VM1 module .outputs.vm ID, and that's it. Exactly the same thing we're using for the outputs for our subnet ID and NSG ID. And finally, in our parameters file, we are using our schema, as you can see. And here I only specified in the parameters the admin username. This is our Azure user, and admin password is testing 1234556. And that's it. That's the whole file for creating two VMs in one subnet with NSG rule, and that's it. I will now save. It's already saved. Now let's try to deploy our file. We will open a new terminal, and this time I will use this simple command: az group deployment group create, the name of our resource group, the name of our main bicep file, and finally, of course, parameters.json. Let me hit on enter, and we are getting the warning that we need to use secure string for our admin password and of course our admin username, because we don't want to use them in the plain text, but this is just a simple scenario. How can we create more resources with more than one modules, of course. Let me see if we can create our virtual machine. And after some time, you can see that our provisioning was successful. And finally, let me go to our Azure portal. I will go to my resource group. This is my resource group 1. And here, as you can see, we have all resources that we specify through our bicep file. The only thing that was necessary to change is the location of our resource group. So if you're getting an error in East-US location, just simply create new resource group and it will work. Here you can see we have our NSG, we have our VNet. If I go to my VNet, this is our address space. We have one subnet. And then if you go to our RG once again, to our resource group, let me go once again to our resource group. Here we can check, of course, our NSG. Our NSG is attached to subnet. As you can see, we have allow SSH, and we have two VMs, two NICs. Both these VMs have their respective NSGs, and you can, of course, now go, for example, we don't have public IP address, we have only private IP address, but there is no matter. You can go to your serial console and you can first enable this boot, and you can apply and of course continue to work. That's it. This was just a simple example. I will now delete all resources from this storage account, and finally this was just a little exercise. How can we create multiple resources using our different models, of course, with multi-models. Let's go to our next chapter. Now let's see another example. How can we create exactly the same virtual machine, but this time I want to create something called availability set. If I go to my portal, let me go to my virtual machine. Let me click on create, and for example I can choose my Azure subscription. I can create my new resource group. This will be, for example, VM1, and now I can choose availability option. You can choose something called availability set. It will automatically distribute your VMs across multiple fault domains. If you click here, you can create your availability set. I don't have any availability set right now. Let me hit on create, and here we need to add a name, choose our fault domain, you choose our update domain. Here we can add 2 or more VMs in this availability set, but it will ensure that only one will be available during some planned maintenance or some different failures. With the fault domain, you can choose to 3 fault domains, as you can see, and then in the update domain, here virtual machine in the same fault domain share the same common power source and physical networks switch, and here in the update domain you can add up to 20 update domains, and virtual machine in the same update domain will be restarted together during planned maintenance, and that's all. That's the whole point of availability set. Let me now go to our Visual Studio Code. This is our, we don't have resource group, I deleted in the previous chapter, so I will first add my folder. This is our P2 folder. Let me click on select, and here, as you can see, we have a whole new setup of modules and parameters. I will now simply remove this txt file. It's really save time. If you want, you can create your own infrastructure, just like here from your Visual Studio Code. But here, when you're using something already, sorry, this is Bicep, when you create your infrastructure before deploying, then it's easier to you to understand what are we doing. Here, as you can see, I will once again use my JSON parameters with my username and password. Here in the modules, we have set up our AWS Bicep. As you can see, nothing special. We need to add our availability set, the name for our availability set, the location, and that's it. This is our resource with name, location, and we want to create 2 full domains and 2 update domains, and name is aligned. Of course, we are using output. VM Bicep is exactly the same, as you can see, and we will just add some different storage profiles here and different VM size. I will use my previous script to add these new values, and you can see we have our VNet and in our new files, our main files, we are setting our parameter for our location group, for our resource group, location, VNet parameters like VNet, subnet name, description, and everything else is the same, just like from previous chapter. It really doesn't matter. We don't have storage account for boot diagnostic. We don't have public IPs for our VMs and so on and so forth. This is just a simple example. How can, if you want, you can create another module for public IP address and then add this module here, add your resource to your VM, to VNet, and so on and so forth. But I want to try to be to these examples be easy to understand. How can we work with multiple resources and multiple modules? Let me first go to my VM Bicep, and I will continue when I change my image reference and VM sizes. If you ask yourself why I'm changing my image reference and VM size, simply to avoid failed deployments and to keep this as easy as possible. Let's go to our file and we can save our file. If it's not saved, I will now go to our terminal. Let's create a new resource group. I will type AZ group create. If you remember, I deleted my resource group in the previous chapter, and this time we need to create our new resource group. We already know how can we create our resource group. And finally, before that, we need to add a name for resource group. It will be dash name. This will be rg1 again, and dash location. You can use PowerShell commands if you want, but I want to use my Azure CLI, and that's it. Let's try to run this to create this group. Group is created, and finally I will now see, yes, we have our old this is from previous chapter. We are using our AZ deployment group create. The name of our resource group template file is main bicep, and we are adding our parameters file. Let's hit on enter and see what we are getting. Of course, we are getting the same warning for our VM, for our plain text, of course, and after that we will see if this deployment was successful. Well, after a few minutes, we're getting our message that our provision is succeeded. Let me just go to our portal to confirm this. let me refresh this. This is our RG1. And now if I go to inside our RG1, you can see that we have our availability set. And if I go inside that availability set, in the overview, you can see that VM1 is running. It is located in one update. We have two updates and two fault domains. As you can see, the first one is in fault domain 1 and update domain 1, and the second one is in the 0 fault domain and update domain is 0. Okay, I will now go to my resource group and delete all these resources. Let me just click on delete and click on delete. Once again, this was just a simple exercise, but from real world project. If we want to use this virtual machine, simple add public IP address and storage account. You already know how to create this and how to put this in your VM Bicep file. Of course, if you're using artificial intelligence for coding, well, I'm not recommending you to do this, because when you try to, or if you're using some old script, then the main problem, you will get in an error, because this provider must be, as you can see, if I, for example, go and after my Microsoft.network/network interfaces, and if I add monkey at, you can choose a different APIs. Of course, the best practice is to use the latest API version for this provider, resource provider, of course. And if you're using some old provider, for example, from 2023 or 22, it will not work. Simple deployment will not fail, because all regions support the latest APIs. So you have to choose or simply add the latest API. That's it. Thank you for watching. One of the most common deployments in Bicep world is load balancing or load balancer with two virtual machines. I will now simply show you how can you deploy this load balancer. If you go to our P3 file, we have defined, I have defined my parameters and my main bicep. Here I can check my load balancing bicep. I have added parameters for location, string, for load balancer name, and public IP address. It is a string, of course. Then for the resource, I added my symbolic name, of course, add this name and location. It must be standard. Here the name is load balancer front end. We are using our public IP address. We are defining our backend pool, health probe, of course. And here for the load balancing rule, HTTP rule, we defined our all child resources, as you can see, and everything else. Then we defined our public IP address with our location, public IP name, and so on. It is static, of course. Then in VM Bicep, I have defined two virtual machines, as you can see, with a different set of parameters: location, VM name, subnet ID, NSG ID, load balancing backend pool ID. Because these two VMs will be part of this backend pool, we defined our admin username and admin password, and custom data string. Our custom data string are, as you can see, our two VMs. Then in the VNet with NSG, I defined our location, VNet name, subnet name, and NSG name. We have two rules, allow SSH and allow HTTP. And finally, this is our VNet, subnet name, and so on and so forth. Then in the parameters name, I added my location as West Europe. So we need to create a new resource group. This is my VNet name, my subnet name, my NSG name, public IP address, my load balancer, VM1, VM2, my username and password. And finally, this is our main bicep file. Let's go to terminal, and then we will simply type to create new resource group. This will be AZ group create. As we already know, we need to add a name for our RG1 name group. Let me just go to my, this is from previous deployment. I will just delete this RG1. Then after that we will define our RG1 and location. Location is, let me just see, West Europe. So we will add our West Europe as our destination, as our region. Let me just check, is this deleting? And finally, let's hit on enter to create our resource group. Our resource group is created, and finally we will use our easy deployment group create, resource group RG1, template main bicep, and parameters are parameters.json. Let me hit on enter and let's see if this deployment work. Of course, we are getting the warning of our admin user, admin password. And it is running, of course. Finally, our deployment is succeeded. If I go to our, for example, terminal, right click and click on Open Visualizer, you can see what we achieved. That's the whole infrastructure. We have one backend pool with two virtual machines, public IP that is attached on our load balancer. We have one VNet, this is our subnet, and NSG is attached to our subnet. So if I now go to our portal, let me go to my resource group. This is our resource group 1 located in West Europe. You can see that we have these resources that we just created. This is my load balancer. If I go inside my load balancer, and if I go to front-end IP address, you can see that we have successfully attached public IP address. If I go to backend pool, we have one backend pool with two virtual machines, VM1 and VM2. Let's go to health probes. We have one health probe. If I go to load balancer role, we have one successful role added. Now, let me go to my VNet. This is our address space. This is our subnet. As you can see, NSG is attached to this subnet. As you can see, this is our NSG rule. And for the inbound rule, we specify that we want to create allow HTTP and allow SSH role. Then if I go to one of my VM, this is standard B1S size with Linux 2204. By the way, this 2204 is working, distribution is working version in all regions, so be careful when you deploy VMs behind your load balancer. Sometimes 24.04 will not work, just to remind you. And then, as you can see, we don't have public IP address, we have private IP address. And now we can continue to, for example, add our storage account, for example. Okay, yes, we can define this in our bicep file, but this is just a simple example of how can we create something from bicep file, and then with the help of our Azure portal we can continue working from here. And just like that, let me try to connect to my VM. And of course we are connected onto our VM. Let me just check where we are, and that's it. And now we can continue working with our VM. And this is it. That's the whole point of using our script. I will now delete the whole resource group, of course, and that's the end of this exercise. This was the real world example, enterprise example. How can you create load balancer with two virtual machines? Of course, you can use custom script extension if you want for this to add onto these VMs, but I want to make it simple just to show you another example. How can you work with multiple modules and parameters? And now let's see if we can deploy application gateway with pet base rule. So I already gone ahead and create the whole script, as you can see. So in our modules we have application gateway bicep. As you can see, we already added without description location, subnet ID, public IP ID, VM1 private and VM2 private. This is our resource application gateway. Name is demo app gateway. Location is Central US. I already gone ahead and create our RG1 located in Central US. Then we are adding our gateway IP configurations, front-end IP configuration, front-end IP ports, backend address pool. As you can see, we have video pool and images pool. This is our backend HTTP setting collection. It listens on port 80. We add our listener, our URL path for video rules and images rule. So all traffic that contains video in this path will go to videos pool, and all that contains images rule will go to images rule. This is a very well known example, and this is our routing request. As you can see, we configure everything here. In the network file we have our VNet and location. This is our VNet resource, subnet, application gateway subnet. As you can see, this is our VN subnet, and we are using NSG with SSH and HTTP roles, and this is our outputs. Then in the VM bicep we have our VM name, subnet ID, admin username. We're using secure string as our admin password. This is our network interface card, as you can see. this is our resource VM. We are using Ubuntu 22.04 because, as I already mentioned in the previous lesson, this distribution is allowed in any resource, in any region. And this we are using for network interface, we are using our network ID, as you can see, and for diagnostic profile, we are using our storage URL. Boot diagnostic, this is for our boot diagnostic. And finally, this is our custom script extension. It will install nginx plus custom message, and this is our bash script, sudo apt get update and sudo apt install nginx, and this will add this message coming from our VM1 and VM2, and it will be located in /var/www/html-index.html file. Finally, in our parameters, I added all value like location. This is our location. Let me just change this to Central US. And this is the name of our VNet, admin username, my password, and the storage account name. Finally, in our main bicep file, we have our parameters for location, VNet, VM username, admin password, storage account name, and this is our network module. As you can see, storage account for boot diagnostic, storage URL for our endpoint blob. This is our output, of course, for videos, VM1, and for images. Of course, this is our application gateway module. For VM1 and VM2, we are using exactly the same module. This is our VM Bicep. Now, let me save this. Save all. I will now run our script. And finally, let's see if we can deploy this. And finally, after 15 minutes of waiting, our deployment succeeded. As you can see, provision state is succeeded. There is a lot of things that you need to set up before this example. So as you can see, first, there is a lot of things that you need to do in our application gateway. This is a very, very common infrastructure, but sometimes it's really difficult to understand all of these settings that you need to set up. And if you're using, for example, artificial intelligence, you will get a lot of errors. So the best way to learn is to get this file, this bicep infrastructure for application gateway with pet-based role, and then go step by step and see what are we trying to achieve. Of course, this was example with parameters, and if you can see in our terminal, there is a lot of things that need to be configured. If I go, for example, right click and open visualizer, you can see that we have our application gateway that is in front of our two VMs. Our two VMs is in the separate backend pools. One is video, one is images. Of course, in both of these VMs, we installed custom script extension, one for images, one for videos, and of course, public IP address and VNet, and NSG is located in our subnet. So let me just go to I will expand this. This is our RG1. as you can see, and this is our resources. We have a lot of resources. Now if I go to our demo app gateway, you can see that this is standard version 2. We have configured our WAF, Web Application Firewall. It is a standard version 2. If I go to backend pools, you can see that we have one pool for video pool and one for images pool. Let's go inside our pool. You can see that this is the private IP of our images VM. And if I go step back, you can see that we have our video pool. This comes from our VM. Now another thing is that we configured our backend settings. This is our HTTP settings that listen on port 80 and it uses protocol HTTP. If I go to front end IP address, we have configured our public IP address. I will simply copy this public IP address, and then if I go to listener, we have one listener that listens on port 80. This is our routing rule. And if I go to rule, you can see that we have our routing rule and that listen on priority 100. And finally in the backend rules, we have our path-based rules, videos and images. So what does that mean? This means that every time that videos, for example, word videos comes up in your HTTP, in your URL, that link will go directly to the videos VM and the images will go to images VM. This is exactly what we want to achieve. Now if you can get a welcoming message, that this message comes from our VM, you can simply go to backend health and check the status of your images and videos pool, and you can see that it is healthy. Success, it received 200 status code, both of our images pool. Let me now go to our demo gateway and I will now go to one of our VM. Let me go to my images VM. We don't have public IP address, so we can go to our serial console and we can simply log into our VM, and after some time you can see that we have our index HTML. So for example, I can run sudo nano and the name of our index.html, and if I open, you can see that this message is coming from VM images. So everything is working, and I really don't know the reason why can we get the message on our VM. But never mind, we just saw how can we work with complex, how can we create and deploy complex bicep file. Just to remind you, we created two VMs in one subnet with one NSG located on our subnet, attached on our subnet, of course. Then on both of our VNets, we installed custom script extension, and then we added application gateway, one with two backend pools. One pool is for images file and one is for videos file. So this is a very, very common infrastructure in Azure, and now we can delete our resources. Of course, before you deploy this script, you can run what if command, and with what if command you can see how many resources can you deploy. And that's it. This was one of the hardest examples that we will see in this course. So this is just to see that we can work on different that we can work with different kinds of resources. Thank you for watching. Well, we saw enough working with parameters.json file and working with modules. In this lesson, I want to create two simple virtual machines located in the same region but in different virtual networks. Both of these machines are the script will be located in our main.bicep. As you can see, so we are adding parameters for location, vmadmin username, vmadmin password, and storage account name. We are creating also storage account, resource nsg1 with rule to allow SSH and allow HTTP. Then we are creating winet1, as you can see, 10.1.0.0/16 and /24. This is subnet 1, and we are creating our public IP NSG2 for our NSG rules, with exactly the same rule for winet2 and public IP nic1, vm1, and custom script extension 1. As you can see, we have some bash script to execute, sudo apt update, and to install nginx, and we will get this message that will come from vn1, of course. And of course, exactly the same thing for our vm2, and this is our custom script extension. And now all values are located for vm1 are located in vm1.bicep.param. As you can see, we are now have a different kind of icon, and we are using a different term using. And of course, we need to add our path to our main bicep. So the location is CentralOS. Admin username for our VM1 is Azure user1, and of course this is our VM admin password and storage account name. Exactly the same thing we're having in our vm2.bicep param. We are using our main bicep. This is the path. Location is CentralOS, VM admin name, VM admin password, and storage account name. So let's try to deploy this. I will now go to File and Save All. Then let's go to Terminal. We need to create a new resource group because, if you remember, we deleted our resource group. I will go to my portal, and you can see we don't have any resource group. So we need to type az group create. Let's add a name for our resource group. This will be rg1, and a location will be, for example, if I remember, CentralOS, we can add then CentralOS. Let's hit on enter. As you can see, provisioning state is succeeded, and as you can see, we are now running a different kind of, let me just delete the wrong name of our resource group, and we are now running az deployment group create resource group. This is our rg1, if you remember. And finally, for the parameters, we are adding vm.bicep param. So we are creating the first VM with this, and I hope that we will be able to create this virtual machine. Well, we are getting this JSON message that our provisioning state is succeeded. I will now go to my portal. Let me refresh my resource manager. This is our RG1 located in Central US. As you can see, we created both of our VMs, and we have both of our VMs ready in different VNets. This one is running. This is a standard B1S. This is our public IP address, as you can see. If I copy this address, we should be able to see that this message comes from VM1. And then if I copy the public address of our second VM, let me go to my second VM, paste it here. You can see that this message comes from our VM2. So just like that, we created two virtual machines in two different networks. And you can see this is our VNet 1, this is our address space, subnets, this is our subnets, NSG is added to this VNet. And if you go to our RG1 to our VNet 2, there is also different address space, and this subnet is also has different IPv version 4 address or subnet address. Now, if I go back to our RG1, you can see that both of these machines, let me just go to my Bicep visualizer, and this is what we created with just a simple main bicep and two parameters file at bicep. So this is another way how can you deploy your virtual machines. I hope that this was helpful. Now you know another example how to create virtual machines by using these parameters, .bicep parameters. Now that you know how can we create this infrastructure, I want to use something called peering connection. If you go to one of these virtual network, for example VNet 1, if I scroll down to the peerings, we can create a network peering. So you can see it is enabled to seamlessly connect two virtual networks or more virtual networks, of course, and the virtual network will appear as one for the connectivity purposes. Let me go now to our Visual Studio Code. I'm using exactly the same script with bicep param for VM1 and VM2, but in the main bicep I added, just let me scroll down, added this peering connection. As you can see, resources VNet 1 to VNet 2. This is our provider and API. Name is VNet 1 to VNet 2. Parent VNet is VNet 1. Allow virtual network access is set to true. Also allow forwarded traffic to true. Allow gateway transit false, and allow gateway transit gateways is false. So for the remote virtual network, we need to add the ID of our VNet 2. Exactly the same thing we can do for the second VNet, and exactly the same, but this time is VNet 2 to VNet 1, and VNet 1 ID must be added here. And the rest is the same. So I will now go and save all. we are using exactly the same deployment. And let's see if we can create our peering connection links. After maybe 1 minute, our provisioning state is succeeded. Let's hit on our portal and let me refresh this. Now I can go to my VNet 1, for example, and if I go to peerings, you can see that we successfully created that pairing, VNet 1 to VNet 2. It's fully synchronized and connected. You can click here and add exactly the same thing that we did in with our bicep file. If I go to VNet 2, let's go to pairings. We have our VNet 2 to VNet 1. And now I will go back to our virtual network. Let me go to VM1. I will simply use my serial console to log into my console, of course, to my VM1. We can use command prompt, but let's see how can we connect. Of course, I will add my username and password. Let me just go here and check my username and password. It's Azure user 1. This is for VM1. I will type Azure user 1 and my password. And we are connected. Now let me just open this in another tab. So we need to go to our resource group once again. I will go to my VM2 and then let me copy this private IP address of our VM2. Then I will now simply type ping and let me add this private IP address. And now let's try to ping our, let me just hit this right, and finally you can see that we can now use, or our machines can talk. So ping is working. I will now type Control Z. As you can see, it is stopped, and if I go back to our VM2, let's try to use once again our serial console. The password is the username is Azure user 2. The password is the same. So we're waiting for connection to our VM2. So we are connecting. Let me run my Azure user 2 and I will add my password. and now we are pinging the private IP address of our VNet 1. And you can see we can talk to from VM1 to VM2. And that's it. This is how it's easy to set up your, I will now hit on Control Z to stop this. You can see how it's easy to establish a peering connection between two VNets using just these three files in our Visual Studio Code. Of course, I will now go and delete all resources that we created during this practice, during this bicep param examples. And that's it. Thank you for watching. I will now hit on delete resource group, hit on the name of our resource group, apply this, force delete, and thank you for watching. During the recording of this course, I received a question: can we deploy Azure Container Services or AKS, Azure Kubernetes Service, in our with the help of our bicep? Yes, we can. I will use again main bicep file. This time we will be provisioning our cluster, and here I'm adding my location for resource group, AKS cluster name, DNS prefix, agent count, agent VM size, this is standard B2S machines, admin username, SSH public key, so we are not using password. This is my minimum count for node pools from 1 to 3. Of course, this is our resource. Let me just change this to newer versions. This is on preview. Then this is our cluster name, location, DNS prefix, of course. Agent pool is our name for our agent pool profiles. Enable auto scaling is true. OS type is Linux. This is our agent VM size. As you can see, standard B2S. This is our admin username. Key data is SSH public key. Network plugin is Azure. Let me just go to my AKS bicep param with parameters. We are using our path, as you can see, from made.bicep. Here our location is central US, so all values are posted here in this bicep parameters file. So this is our demo AKS cluster. This is our demo AKS DNS. Agent count is 2. This is our agent VM size. Azure user. This is our SSH public key. And parameters minimum count and maximum count is from 1 to 3 for our nodes. Let me just go to our file and save this. First, I need to create a resource group. We don't have any resource group. Or let me just, I think I deleted my resource group. Yes, so we can create another new resource group. Let me type az group create. Then we need to specify the name of our group. Once again, RG1. This is just an example. And then we need to specify our location. This will be once again central US. So we are using a different regions. Our group is, as you can see, created. And now from the previous I will add the name of my parameter, and this is AKS dot Bicep param. Let's hit on enter. And finally, after 10 minutes, our provisioning state comes as succeeded. But before we go to our portal, I must warn you, if you want to create AKS cluster, you must use SSH key. First, you need to generate that key and add this key here. For the security reason, I won't enable this key. This is my private key that was just generated. This key will be deleted, and this whole bicep file for creation of this AKS will be empty. So you must generate your own SSH public key and insert here. How can you generate your public key? Simply go to administrator, go to Windows PowerShell, run this as an admin, and run ssh-keygen -t rsa this b 4096-f environment user profile /.ssh AKS key. So when you do this, go to your C drive, to users, to your profile, find .ssh key and add your public key. Copy that public key here, and then you can run your command to create this AKS. Let me now go to my portal. Let me refresh this page. Here, this is our infrastructure group, as you can see. If we go inside that resource group, you can see that we have generated our AKS cluster. This is virtual machine scale set. We have our virtual network. This is our public IP address. This is our managed identity. And this is our load balancer. If you go to our AKS, sorry, this is network security group. If you go to our here it is. This is just our infrastructure group. This is our demo AKS Kubernetes cluster. Here you can see that it is located in the overview section. It is located in RG1. It's running, succeeded. This is our Kubernetes version 1.33.6. We are using base SKU, free pricing tier, one node pool, and you can attach your container registry if you want. This is our service CIDR, DNS, service IP, and so on and so forth. So we are using standard B2S, just like that we mentioned in our script, and this is located in central US. So now you can connect to your AKS cluster and finally continue to work with your Kubernetes. Then you can add your YAML file and so on, just to show you that this really work with our file, with our bicep. You can check our node pool here. This is our system pool, as you can see, and we are using Ubuntu Linux as our operating system. So I will now go to our resource group and delete. First we will delete our infrastructure group. Let me just delete all these resources because we don't need I can connect to my cluster, but I won't do this. And finally we will delete our RG1. Let me delete this network watcher. Resource group. And finally we will delete this RG1 resource group with our demo AKS. So just like that you can provision your a case cluster, a case resource, but once again, you must add here your generated SSH public key. Thank you for watching, and we will continue. In the previous few hours, we have seen extensive examples and labs if we can and how can we work with different services and the ways in which we can deploy them, as well as which commands we can apply while working in Bicep. Of course, we can go back and forth and practice with a few more real-world projects or examples, such as creating a hub and spoke architecture, deploying different types of services, of other services in their combination. But with the previous examples, you can do it yourself. For example, you can deploy hub and spoke architecture. You can, in the hub network, add virtual appliance. You can, in both spoke networks, add, for example, VMs. On that VMs, you can install some application or add some databases or use user-defined routes, for example, to route traffic. Or there's a number of exercises and real-world examples that you can work with. So that this course would not be too long and boring, in order to remain at a normal time distance, in the next few minutes I will show you that Bicep is not only a tool for creating infrastructure. In fact, Bicep is much more than that. We can also use it for other purposes. For example, as you can see, we can use Bicep for Azure policy and role-based access control. So we can define and assign policies, for example, like deny VM creation in specific regions, or automate role assignments for users, groups, or manage identities. We can use identity and access service, like Enter ID, to create users and groups declaratively, add users to groups, or assign application roles. We can use Bicep for networking and security, create energy rules, firewalls, application gateways, private endpoint configurations, for example, to secure services inside our VNets. We can use Bicep for governance and compliance, to enforce tagging strategies like mandatory tags, to restrict allow location, SKUs, or naming convention. We can use it for automation in CI/CD, for example. We can integrate Bicep with GitHub Actions or Azure DevOps pipelines. We can use, as we already know, .bicep params files for environment-specific deployments like dev, test, and prod. We can use Bicep for data and AI. We can deploy Azure OpenAI, for example, cognitive services, or machine learning workspaces. We can provision datasets, storage accounts, and connect them to AI services. And you can use Bicep also for monitoring and operations, like creating log analytics workspace, define alert rules, and diagnostic settings. So with Biceps, we can do almost everything. So Biceps is not only good for infrastructure. As you can see, it is good for more than enough. So let's see some examples of this just mentioned scenarios and see what we can achieve. Well, now it's time to see how can we deploy AI resource. AI is very popular these days, and let's see how can we create a simple open AI service. But this time we are using bicep file. We have main bicep file and main.bicep parameters file in which we can store our values. First, as you can see in our main bicep file, I already created some parameters for our location resource group. This is parameters for our OpenAI name, SKU name, tags, enable private endpoint. The name for my VNet is my VNet. Subnet name is my subnet. This is our address space. This is our subnet prefix. First, we are creating our VNet. This is our VNet, as you can see, with added parameters, of course. Then we need to use our existing command because we are using our we are creating our subnet, and VNet is parent to this subnet. And then we are creating our OpenAI resource. This is the name for my resource location, what kind of services, SKU name, tags, of course. And finally, I'm creating private endpoint, as you can see, and that's it. In the main bicep file, I'm using, of course, the reference of this main bicep file. We are using OpenAI name, location is central US, SKU name is standard 0, environment is production, owner is me, enable private endpoint is true. So when this said true, if you remember, then our resource will be able to be provisioned. And if it say it's false, then you can skip that in your every time when you add equal false, that resource will not be created, or just like that. And here we are adding our subnet name, VNet name, subnet name, address space, and our subnet prefix. Of course, the first what we need to do is to create our resource group. So I will go to our terminal, and finally let's type az group create, if you remember. Then we need to add the name for our resource group. This will be RG1, for example, and location will be Central US. Let's hit on enter. Sorry, I made a mistake. Let's try now. Our group is created, and then we need to deploy this. First, we will use our well-known template. This will be a well-known command, az deployment group create. You can use, if you want, what if. Then we need to add a resource group. This is RG1. And finally, we need to add our template file, dash file. This file is our main.bicep. And of course, we need to add our parameters. And this is our main.bicep param. Let's hit on enter. Finally, after 2 or 3 minutes, our deployment is returning as succeeded. Let's go to our portal. I will go inside my resource group. We have RG1 resource group located in Central US, if you remember. If we go inside that resource group, we have our enterprise enterprise VNet, we have my OpenAI service, we have my OpenAI service private endpoint, and our network interface card. So if I go to my enterprise VNet, you can see that it is located in Central US. This is our address space. If I go to address space, you can see it here in the subnet. we have OpenAI subnet. Let me go to my private endpoint, and you can see that we have our my OpenAI service private endpoint. And if I go inside it, you can see our resources. Then let me go to my RG. This is my OpenAI service. And here now we can build our own secure copilot and generative applications with Azure OpenAI service. And we can go directly to our Foundry portal to work with our AI services, as you can see. And that's it. This is how can you create your OpenAI service and work with different kinds of different kinds of resources. Sorry. Of course, you can go and create more this in depth, but this is just a simple bicep file that we provision, because I just wanted to show you that it's possible to create different kind of resources, just like AI resources. Let me now delete my whole resource group, because we don't need these resources, these files. So we created Azure OpenAI private endpoint and our virtual network. Thank you for watching. Well, in some of the previous chapter, when we talked about different scenarios that going beyond resource creation, I mentioned some examples for data, AI services, and so on. So there is monitoring and operations option that you can create, or services that you can create. For example, we can enable backup on VM. We can create VM, then resource like Vault, recovery service Vault, for example, and then we can create a different policy for backups and so on and so forth. But in this simple example, I want to show you, let me just check my latest API. I want to show you how can we create log analytics workspace. Just a simple example, nothing special. Here, if you can see, I have, let me just save my files. I have location string, workspace name, SKU. It is per gigabyte. This is default option. Retention days 30 days. You can use tags. This is our log analytics workspace. Location, of course, our outputs, and I'm using main bicep file. As you can see, this is the name of my workspace. Location, exactly SKU, retention days, and tags. Let me go to my terminal and try to deploy this workspace. So we can use this AZ deployment. You can use what if you want, but this is just a simple example. Let me just add, and finally our resources provisioned. As you can see, we already have our RG1, and of course the command for deployment was simple. As you can see, our easy deployment group create, the name of our resource group, template file, and parameters, of course. Now let me go to my portal. I will refresh this page. Let me go to my RG1. In here, this is my Log Analytics workspace. So with the help of Log Analytics workspace, I can now collect all logs from all resources, from whole subscription or tenant, and I can use logs to dig deeper or simply investigate this central repository for collecting all logs from different resources. This was just a simple explanation of how can we create Log Analytics workspace. By the way, if I go to Marketplace and if I type, for example, Log Analytics workspace, I can create Log Analytics workspace just like that. And here I can add my, for example, a resource group. I will add some new name, for example, low 1. It will be located in Central US. Let's go next to tags to review and create. And finally I can hit on create. So this is how can you create Log Analytics workspace from portal, and how can you create with the help of Bicep file. It's really easy and nothing complicated. I will now wait for this deployment to be finished and delete all my resources with my, I will leave my resource group because we need our resource group for now. Here it is. This is our Log Analytics workspace. You can see nothing special, exactly the same, just like the one that we created with the help of our Log Analytics, with the help of our Bicep file. I will now go and delete my resources from this resource group. Let me just confirm delete, and I will hit on delete to delete these resources. So in the previous hours we really learned a lot, but we didn't learn how to provision our policy option. If I go to my portal, you can see that if you go to, for example, create resource and simply type policy, we can go to policy service, and here we can run policy. We can go to our policy service, and here we can add a different kind of definitions or assignment. So as you can see, there is a lot of policy or categories that you can choose from compute to AI to app management, automation, and so on and so forth. So I want to try to create a policy from our Bicep file. Here, if I go to our Visual Studio Code, there is a different elements that I want to achieve, different goals that I want to achieve. First, we need to specify our target scope, because if you want to use policy, you must add your target scope, subscription or management group or tenant. Then we need to add our resources. This is deny East US VM, and display name will be deny VM creation in East US. This policy will prevent creation of virtual machines in the East US region. As you can see, I specified my location, my East US, of course, location, and effect is deny. In main parameters file, I only use this main Bicep because I don't have any value here. And now this is a special folder for commands, because commands is really different from the other one. This time we will use AZ sub, the AZ deployment sub create. Location is, let me just change this to our East US, for example, East US location. Template file is main bicep file and parameters is main bicep parameters. Let me just copy. First we need to save, of course, all. I will now copy this command and paste it here. Let me hit on enter. And let's try to use this without bicep parameters. It's running, as you can see. So after a minute or two, our provisioning state for our policy is succeeded. Let me go to my portal, and if I go to policy, we can go, for example, to definitions. I will choose my policy type. Let's go to custom. Let's go to apply. And here it is. This is our policy. But this policy is on subscription level. As you can see, this is a custom policy. And if I go inside that policy, this is our JSON file, our definition that we added in our bicep file. So here in the properties, you can see the display name is deny VM creation in East US. Policy type is custom. Mode is all. It also prevents creation of virtual machine in East US region. And so on. This is version 1.0.0. Field is location. Location is East US and effect is deny. This is our subscription ID and so on and so forth. So now I can assign this policy, for example, to one of my resource group, and with the help of this policy will have a deny effect in our East US region. So if you want to create a virtual machine in East US region, you can't because of this policy. And now with the combination of our policy, I can choose, for example, RG11 and add this policy or assign this policy, this custom policy that we created on our subscription level, to our resource group. I will choose select. So this is a combination. How can you work with bicep file and, for example, from Azure resources? I can make exclusion if I want. This policy enforcement will be enabled. Let's go to next. The policy has no parameters. We can add some non-compliance message, for example, this is allowed or something like that, and let's go and create this policy. As you can see, we successfully created our policy, and it takes around 5 to 15 minutes to take effect. If we go to policy, let's go to our assignment. Now, as you can see, deny VM creation for East US is taking a full effect. This is our policy, and this is Azure subscription and RG11. If I now go to, for example, virtual machine, let me try to create RG11 East US VM 2, for example, and if I try to configure something else, let's, for example, generate a new pair. This will be, we will leave everything as it is. Let's go to review and create. As you can see, validation failed. If I click here to see details, you can see that resource VM2 was disallowed by policy, and that was our policy that we created, this custom policy that we created via Bicep file and with the help of Azure portal. We are added this policy to our resource group. So I will now go to my policy, and in the assignment, let me click on delete assignment. I will hit on yes, and we successfully deleted our assignment. It will take for about 30 minutes to create, to take this policy. As you can see, that changes take policy around 30 minutes to take effect. And now if I want to go back to my virtual machines, I can now build my VMs here in my EastUS. So this was just a simple exercise to see, to show you how can you create and work interchangeably with Bicep file and, for example, policy. When you define the policy in your Bicep file, sometimes it can really be tricky, because there is a lot of things that you need to set up. I will now go to my resource groups and delete my RG1 resource group. This is an empty resource group because this was the last exercise in this course. We really learned a lot. I will now delete my other resource group. This is RG11, and let me hit on delete. Most of these Bicep files will be available to you, but this policy I will not make it available. Go through that policy and create. This is an exercise for you. This is some kind of homework, and create it by your own. Thank you for watching, and I will hope you that you know how to work with policy now. If you want to continue to improve and learn more about Bicep, the logical step would be to move to a higher level. Although this course also offered you a lot, from the very basic to some more advanced exercises. If you go to the official page of Microsoft Bicep, as you can see in your screen, we can see that we have many examples of individual resources that we can exercise. There are a few things that I didn't show you in this course, among others, two combinations of Bicep's work and GitHub Actions and CI/CD. Combining Bicep with GitHub Actions is one of the most common ways to set up CI/CD for Azure infrastructure. The idea is to treat your Bicep template as code, store them in a GitHub repo, and then automate deployment whenever changes are pushed. So how it works? First, you create a repository. Your Bicep files like main.bicep or .bicep params live in GitHub. GitHub Actions run on triggers like push to main branch. Then you need to log in to your Azure to workflow authenticate to Azure using a service principal or OpenID Connect, and then deployment. So the workflow runs as AZ deployment group create or AZ deployment sub create, depending on your scope. Then we can use Bicep for modules and registry. There is something called Bicep registry. You can publish modules to Azure Container Registry or the Bicep registry and reuse them as standardized building blocks across project. This is especially popular in enterprise environments where teams share common modules. Then we can use template specs, allow you to publish a Bicep file as a specification in Azure, so other teams can use a standardized template it also ensures consistency and governance. You can use for decompilation and transpilation. You can convert existing ARM.json templates into Bicep using az bicep decompile command, or the reverse, az bicep build to generate ARM.json for Bicep, useful for validation. You can use linting and best practice checks with az bicep lint. You can provide warnings about style issues, unused parameters, on non-optimal constructs. If you have more than 500 lines of code, for example, you can use Azure Bicep lint. Then you can, of course, enforce DevOps discipline and code quality, cross-tenant and cross-subscription deployment. Bicep can deploy resources across different subscription or even different tenants. So it is very useful for multi-cloud and multi-organizations scenarios. Then we really talked a lot about outputs, references, extract values for example, connection strings, resource IDs from one deployment and pass them to another, essential for chaining resources together in CID, CD pipelines. Then you can use conditionals and loops. You can use it for dynamically create resources, multiple subnets or multiple enter ID users, for example. Reduce code duplication and increases flexibility. All of these require a large number of hours spent writing scripts and Bicep files. But the most important thing is to go step by step and understand how it works. You can always use AI as a generator, but take my word for it, many have tried it and gave up very quickly, because there are too many errors, so you need more time to correct the errors than to write a new file. Or simply, for that wasted time, you can go to our Azure portal and create them manually. If you come or came from the Azure world to this course, you can learn, you have the option to learn or chance to learn the basic of biceps. Then it is very good and you will need it in your future work. So, as you can see in your screen, we have official bicep page from Microsoft.learn. And here we can see a very informative page. And if you're starting, there is an option for example, quick start, how can you create your bicep file, and so on. Then the main thing is tutorials, samples, and here in these samples you can find any, for example, AI and machine AI search, for example. Here you can find how can you create some basic bicep file, as you can see. Then we have something called Azure Quick Start Templates. If I open this in a new page, you can see how can you, for example, deploy this, and so on. You can browse your code, and very, very good and informative samples for Azure services, of course. For example, you can create Azure Cosmos DB. We learn how can we create, for example, let me just find database for my SQL database. Here it is. There is a full option or full script. How can you create? Of course, you can open this and use Bicep Quick Templates to create your SQL Server and database. Simply, you can go and visualize this. As you can see, how it looks like, and see, you can see your code if you want. This is how it looks like in our file. Then it's always good to check all these options. Let me go just step back And here you have also the concept, all data files, parameters, how can you use loops, conditions, extensions, scope, functions, operators, user-defined scopes. Most of this we already learned through our examples. And then you have to how-to option to explore, deploy, and so on. Don't be lazy. Go and check all these. Also, there is a reference for all these resources. Don't be lazy. Just go and check all this complete page. What is Bicep? Learn more and practice, practice, practice. Without practice, there is no improvement. So that was our lesson about what is your next step or what we didn't cover in this course. Now it's time to do a kind of checkout for this course, which I never been good at. Everything I had to say, I said in the previous chapters. Why Bicep and how to train it. This was a long course for this kind of learning, without being a preparation for passing the certificates or preparing for the certificates. Of course, I could have created dozens more examples that we could combine with various Azure resources, but there is no need. My advice is to combine writing Bicep files or script and using the Azure portal to reach the maximum in your daily work. In the end, like everything in life and on this planet, Bicep is not perfect. It is far from perfect. Sometimes you have to use automation and a portal to get the job done. But the daily exercise will make you better and give you some new perspectives. Thank you for your trust, and I hope you had as much fun practicing and listening as I did recording this course. All the best in your further studies and work at Azure. And don't forget to subscribe to my YouTube channel, and if you want to connect, find me on LinkedIn by using my first name and last name. And we can talk, of course, not about Bicep, about AWS, about Azure, and everything else. Once again, all the best in your further studies and work at Azure.